finding out all these factors, you have to validate these factors. The validating those factors is called hypothesis testing. Even after validating these factors, that is not an end. You'll have to conduct an experiment and fix those factors. Therefore, please note that we have not completed the course. We have not come to a conclusion. So that don't say that I will do that, I will do this and all. We will all keep it in the table. Our choice is there, but we have to take the choice wisely, right? And then proceed further, right? Right now, we are only identify the factors. What method you follow, you are the king. You select it because you are an expert in your field. Thank you.
All right. Thank you, sir. So I suggest all of you to park the topic of brainstorming for a little while. We will just go back to understand this particular topic, capability analysis. You remember, all of you, capability analysis. How do you measure the capability? You can measure traditional yield. Am I right? All of you? All of you agree? Traditional yield. What is traditional yield? Come on, you need to speak out. Output by input.
Traditionally, yes. What are all the actual we are getting without a defect?
Yes. So another thing is first pass yield, where the output minus rework, then divide by input. Right? And this output minus rework. Because now we are a little more matured. The rework is also considered a failure. So we are subtracting it to understand our capability. And another thing is DPMO. So what is DPMO? All of you?
Defects per million.
Defects per million opportunity.
Dr. Arge should have given you a template. You can try to learn all the templates, right? Whatever he has given. And he will also be mailing all of you all these things. So defects per million opportunities, GEMS experiment you might have done. And another thing is PPM. What is PPM?
Part per million.
Yeah, parts per million. And another thing is
Parts per million.
Yeah, parts per million I have written. And DPMO is meant for defects. Parts per million is meant for defectives, right? And then we have CPCPK. What is the CPCPK?
Process capability and process capability index.
Process capability indices. Out of this, CP is called potential process capability ratio. CP is called potential process capability ratio. It only gives the potential. Like expert have told potential factor, it doesn't mean it is root cause, right? But then you have to go next step. The next step is CPK. The CPK is the real process capability index. And there is one more thing called the PPPPK. So what is this PPPPK? What is this PPPPK? Process performance indices. Capability is important or performance is important?
Performance.
Okay. So you have to deep dive then, right? Don't stop at process capability indices. You should also dive into process performance indices, right? So which we will be doing it on day number 5. And then there is one more thing. What is that? Sigma level. So how many ways of measuring the, the capability you see here? If there is any other method, you can still, adopt it. But all of them are connected. Ultimately, it is telling you what can I expect from the process. Ultimately, it is telling you what can I expect from the process. If my sigma level is 6, what does it mean? What can I expect? The success rate is high performance. The success rate is 99.99966%.
3.4 defects per million.
Exactly. The failure rate is 3.4 DPMO, provided the tolerance is one-sided. Right? So ultimately, everything is, boiling down to the success rate and the failure rate, right? And similarly, if my CPK is equal to 2, it means sigma level is, tell me what is the sigma level now? Come on, I am adding a condition. CP equal to CPK. and CPK equal to 2, it means sigma level is 6. It means sigma level is 6. So what is this CP? What is this CPK? CP is customer tolerance divided by process tolerance. All of you, are you familiar with the terms? Customer tolerance, process tolerance. What is customer tolerance?
That is a customer expectation.
USL minus LSL. Am I right? Upper spec minus lower spec. Then what is process tolerance? What is process tolerance? UCL minus LCL, which will be equal to 6 times of standard deviation, If I calculate a ratio between customer tolerance and process tolerance, the ratio obtained is called potential process capability ratio. All of you with me? Now look at my formula of CP. CP is nothing but, formula is very simple. CP equal to USL minus LSL divided by 6 times sigma. Now, what are the elements that is participating in my formula? Upper spec, lower spec is participating, am I right?
Yes, sir.
And then 6 sigma. What is sigma here?
Sigma is error.
Sigma is error, or you can call it variation. So only you are using variation. How many of you know quality is not only a function of variation? Quality is also a function of variation and one more thing. What is that one more thing? Can you fill up this blank?
Variation and capability, I think.
See, statistical definition of quality. Am I right?
Variation.
Central tendency.
Central. Okay.
Let us say I conduct your certification exam. I conduct a certification exam. The class average is 85. Right? Class standard deviation. Class average is 85. Class standard deviation is just 2 marks. What is your understanding about the training process? Everybody, did well?
87 to 83.
Come again. What are you telling, Santosh? 99 point? What do you understand, all of you? When I say class average is 85, class standard deviation is 2. What do you understand? The marks scored by the student, student is between
79 to
very good, 79 to
91.
That's all. Almost all the students, or to be precise, 99.73 we use, right? Almost all the students would have scored between 79 and 91. Now, are you happy with the level of training, or are you happy with the performance of your students? Tell me. You should be happy, am I right? Let me give another scenario where average is not 85. Average is, let us say, 45. Standard deviation is 2. Now, are you happy with the performance of your student? Now, what will be the mark of your students?
51 to 39.
50, not 51.
39 to
39, right?
39 to 50.
I am definitely not happy. And what is the reason for your unhappiness? Is it the variation? Variation is same. Variation is same, standard deviation is 2 in both cases.
average.
Now the reason for the problem is average. So that is why I have given a statistical definition. What is the statistical definition? Quality is a function of
Variation plus central tendency.
2 things, variation plus central tendency. So you should always look at both. Variation, you can see through range. You can see through standard deviation. You can see through variance. But central tendency, you can see through average. You can see through mode. You can see through median. Whichever makes sense, please use it. Whichever makes sense. But definitely there should be one central tendency you should keep an eye. Definitely there should be one variation you should keep an eye. All of you agree with me?
Yes.
Sir.
So CP may become useless at times. CP may become useless. When the CP will become useless? If central tendency is not at the target. Can I say like that? If central tendency is not at the target, your CP will become useless. Am I correct or not?
Sir.
Why? Because if you look at the formula of the CP, look at the formula of the CP. What is there in the formula of the CP? Only variation is there. Am I right?
Yes.
Only variation is there. No central tendency. However, that is why we require one more matrix called CPK. CPK involves both variation and central tendency. So, which is best measure now? CP or CPK?
CPK.
CPK is the best measure. So hereafter, I strongly suggest all of you to conduct the capability analysis only after ensuring that your process is under statistical control. After conducting the capability analysis, please look at CPK and not CP. All of you agree with me?
Yes, sir.
Because CP can mislead. Because CP gives only potential capability. And the actual capability you can see through the CPK.
CPK.
An industry standard is CPK must be 1.67 for critical processes. Certain processes are critical.
Yes, it is CP is greater than CPK.
Yes. So certain processes are critical. For example, your learning is critical. You passing in the exam is more critical. Am I right?
Yes, sir.
Yeah.
So we should have a process to ensure your learning, and we should also have a process to ensure all of you pass. Now, which is more critical? Passing the exam is more critical. So we have to make sure we keep it more and more capable. Isn't it? So wherever process is critical, CPK should be 1.67. Wherever it is less critical, you should be happy with 1.33. All of you understand?
Yes, sir.
And
Most of the
ideally,
companies are using CPK 1.33 in their company. I think they are thinking that their level are best.
correct. And also ideally, CPK must be equal to CP. That's the best scenario. Whenever CPK is not equal to CP, what is your understanding? Whenever CPK
the process is going wrong.
Correct. See here, when CPK is equal to CP, both variation and central tendency,
Or
both variation and central tendency,
near to the median means the process is going so less our CPK is good.
yes. See here, when CPK equal to CP, variation is under control, central tendency is also under control, and then when CPK is more than 1.67, it is not only under control, it is also capable. But coming to the other scenario, where CPK is not equal to CP, which means you have problem definitely with the central tendency. Please understand. You have problem definitely with central tendency. Only whenever the process is shifted, only whenever the central tendency is not good, your CPK will differ from CP. Hope you might have experienced it. So now all these kind of logic you will be able to better appreciate. So let us do a small case study. See here, what is written here in the data? Coating thickness.
Coating thickness.
Coating thickness need to be, let us say, 50 micron or something. And the customer has given a specification. Upper spec, 53. Lower spec, 47. So anything between 47 micron and 53 micron, you are okay. And you want to check whether the process is capable or not. So without showing you the formulas, right? I'm just taking you through the Minitab method. Go to stat, go to quality tools. Can you see capability analysis? Capability
Yeah.
analysis for normal data. And now, data, which data contains, which column contains your data? Column number 1, select it. What is your subgroup size? Every time when you take a sample, how many sample you have taken? I have taken 3 sample, which means my subgroup size is 3. Now lower spec. Lower spec is how much? We said 47, right?
47.
Upper spec 53. Now after giving all these things, you can give okay. Now Minitab has done the job for you. Now tell me, what is that you will look at? Will you look at CP or CPK?
CPK we need to look.
Yes, look at your CPK. How much it is?
2.37.
2.37. Are you happy now? Are you happy now?
Yes, sir.
You should be happy. Because
Yes.
requirement is 1.67, but look at your value, 2.37. And moreover, CPK is close to CP. What is it telling you? You are almost at your best.
Tendency as well as the median is same. only.
Central tendency and variation, both you are controlling very well. You are controlling central tendency, you are controlling variation also very well. CPK appearing close to CP means you are currently at your best.
So our graph also showing that giraffe.
Yes, yes. So your capability is close to the potential you got. And the meaning of the other matrices here, PP, PPK, we will deal little later. All right, to all of you?
Yes, sir.
When I look
Yes.
at PP, CPK, my process is appearing like a dotted line. But for the same set of data, when I look at PP, PPK, my process is appearing like a red color line. Considering the dotted line, look at the PPM. PPM is 0. Considering the dotted line, PPM is 0. My process is at the best. Excellence is achieved, no defects at all. But considering the red color line, look at your PPM. How much is the PPM?
393.
394 rejections will happen considering PP, PPK for the same data. So what is this PP, PPK telling? We are going to talk on day number 5. But right now we are talking about CP, CPK, which are called capability indices, not the performance indices. Now tell me, which one your customer will feel? Customer will feel your capability or customer will feel your performance?
Performance, sir.
Oh, very good.
Performance.
So I may know many things about Six Sigma, but what is that I am transforming to you? That is matter. That is very important to you. Am I right?
Yes.
More than my capability, my performance is important to you.
Yes, sir.
Similarly, if you also understand that performance is important than capability, you will start looking at PP, PPK, not CP, CPK. So what is this PP, PPK? How is it different from the CP, CPK? How to calculate? We will be coming back to all the phases again on day number 5 and 6 to make you a black belt. All of you understand?
Yes, sir.
Right now,
Yeah.
we are only giving you, understanding about the tools, but you need to understand deeper so that you can apply, so that you can actually evaluate, and you can also create the tools according to the requirement. So I would like to stop here so that you all can go for the lunch, and then we will be So once again, welcome all of you for the post-lunch session on day number 3, right? And we have Vinod sir also in the meeting. Welcome, sir. All right.
Good afternoon. Thank you, sir.
So this particular session is to help all of you understand what is quantitative analysis and what is hypothesis testing. There are several hypothesis testing we will be doing as part of the Six Sigma project, as part of the improvement project. So what are these tests? know how these tests work, what kind of tools and techniques are required. So that is going to be our agenda now. So that means we are trying to understand about the criticality of a factor. A factor is considered to be critical if the impact is considerable. A factor is considered to be critical if the impact is significant. So what is significant and what is not significant? What is the borderline? See, in many of the times, what we are doing here in the training program is we are trying to understand the borderline. And now the question is, what is the borderline between considering something as significant and something considering as non-significant, right? So that is the bigger question that we are trying to get it answered. So first point is, what is hypothesis testing? And then what is null hypothesis and what is alternate hypothesis? In simple language, hypothesis means statement, right? So hypothesis testing means you are giving me a statement. Whether the statement you are giving me is correct or not, I am going to validate. Because right after the brainstorming, what you have is, you will have plenty of statements. Somebody will say this is going wrong and somebody will say that is going wrong. Temperature is critical. Somebody will say pressure is critical. Somebody will say tool setting is critical. Somebody will say skill level of the operator is critical, whether it is really critical or not. So you need to do some experiment on the statement that has been, given by the experts, given by the stakeholder. And whatever the experiment says, you can go by it. At the same time, you have to make sure the experiment do not mislead you, right? That's very important. So hypothesis testing means we are validating a claim. Claim can be between two groups or claim can be between more than two groups. So a claim about the difference between two or more groups is tested for its trueness in real life. Ultimately, the point is whether the difference is significant or not. A difference to be considered as a difference, it should make a difference in real life. I repeat the statement. A difference to be a difference, it should make a difference in real life. If it makes a difference in the real life, then I will consider the difference as significant. If whatever I observe in the sample study, there is a difference, but in real life, there is no difference. In that case, the difference is insignificant, right? So taking a decision about the significance is called hypothesis testing. It is a decision-making procedure in which a claim about the difference, the factor is critical, and so your output will be impacted. You will definitely see a difference in the output if there is a difference in the input. So the claim about this kind of difference is validated. And difference can be between two groups or difference can be between more than two groups. Temperature at lower value, temperature at higher value. I can always compare what will happen when the temperature is low, medium, and high. So it can be two groups or it can be more than two groups, right? So there are certain statements here you all can easily understand. These kind of statements generally come out after your step number 7. The step number 7 is listing the possible factors and then the probable factors. The probable factors may be critical, may not be critical, right? So one of the probable factor is reaction time. Somebody is saying that, or the team is thinking that reaction time will affect the chemical process yield. And now I want you people to tell me, when there are two variables here, one is reaction time, another one is chemical process yield. Tell me which is X variable here, which is Y variable here. Reaction time is one thing, chemical process yield is other thing. Which is X variable and which is Y variable here? Come on, make it right.
Chemical process yield is X variable.
Okay.
This is Chanchles here. Reaction time is the Y and the pouring temperature is X variable.
No. I am asking you to compare only the first statement, not the first and second. First statement. Reaction time affects process yield. Now the doubt is only between reaction time and process yield. Yes, Yadav.
Actually,
Okay. Reaction time is the X
Okay.
inputs that will affect the process yield.
Very good. Fantastic. Fantastic. All of you agree with Yadav? Arogiraj, you have to change your understanding. Yield is something which is output. Your attendance and your test mark. Now tell me which is input and which is output. Your attendance and your exam mark.
Exam marks is our output and attendance is our input. If
Yeah,
we will give a attendance, then definitely 100%, then definitely achieve a 100% result.
Very
That is
good.
our out.
Always you should know which is X variable, which is Y variable, right? Otherwise, problem solving will be a big confusion, right? Now, second statement, pouring temperature affects casting quality. Now, casting quality is output. Pouring temperature is input.
Yes.
Now, what is the brainstorming team is telling? Hey, handle the pouring temperature carefully. That is they are telling, am I right?
Yeah, yeah.
You are pouring the metal at 400 degrees Celsius also, 410 degrees Celsius also, 420 degrees Celsius also, thinking that the change in the temperature will not affect the end quality. But the brainstorming team is cautioning you, don't do like that. If you are setting the temperature at 400, see to that you are pouring the metal into the die at exactly 400 degrees Celsius. You should not allow the temperature to go down or go up. While actually, no, you are transferring the molten metal from the furnace into the die. So now Y variable is the casting quality. It can be the porosity or it can be surface finish or whatever. The X variable is pouring temperature. Sorting time will affect your on-time delivery. So sorting time is X variable and on-time delivery is Y variable. Now my doubt is when I change these X variable, will there be a change in the Y variable? If I observe that change in the X variable will cause the change in the Y variable, then the X variable you are studying is a critical X factor. All of you understand? When I change the X variable and also change in the Y variable, also observe the change in the Y variable, which means the factor I am experimenting right now is really a critical factor. For example, your attendance and your test mark, is it a critical factor or not? Poor
Attendance is a critical factor.
Yes.
Yeah.
Poor attendance, poor mark, right?
Yeah.
Good attendance, good mark. So attendance is definitely impacting.
Okay, so we can say that Y variable is the dependent variable.
Yes, Y variable is the dependent variable, X variable or the independent variable. Independent variable means you have direct control over it. You can decide what level of attendance you can put in the program.
Okay, got it, sir.
But test mark, depends on these things. What are these things? Test mark depends on your all the attendance and your interaction, the time you spend in going through the recordings, isn't it? That the time you spend on reworking on some of the case studies, like the control chart assignment I have given one. All these things will definitely impact. And similarly, your attendance in the Wednesday classes, Thursday classes, all these things are the input. Now you need to understand, we are trying to validate the statement. There are two types of statement. One is null hypothesis, another one is alternate hypothesis. The null hypothesis is always innocence. Null hypothesis is always your old belief. Null hypothesis is always, statement of equality, which means the previous question is whether the temperature will affect the casting quality or not. What is the belief of my company so far? Can one of you tell me? In my company, they do not care about the temperature. That means what is the belief there? Temperature is not affecting the quality, isn't it?
Yes.
Whatever
There is no relationship between temperature and the quality.
Beautiful. That means there is no relationship between temperature and what you call the quality. So when I say no relationship, when I say there is no impact, when I say no, the situation will be same. Even when the temperature is high or low, I always get the same quality. Then my statement is null hypothesis. So null hypothesis is the statement of no impact, statement of no relationship, statement of equality, statement of no change, statement of no difference. These are all called innocence. I can pass the exam without attending the class. I can pass the exam without, going through any of the material. If you are then passing, it is purely, a fluke. Isn't it? It is purely a random chance. So we'll talk about it. On the other hand, alternate hypothesis is the just opposite. Just opposite is the statement of impact, the statement of inequality, the statement of change, the statement of difference. In order to prove alternate hypothesis, you have to do experiment. But in order to prove null hypothesis, you don't have to do anything because it is already, people believe it in that way. In your company, so far the belief is temperature can vary slightly, slight variation in the temperature is not crucial to the result. This is the belief. No one has to prove it. But if you want your company to believe the alternate hypothesis, you must conduct experiment. You must show data. Then only they will believe. They will believe you. All of you agree with me?
Yes.
That is why we are doing experimentation. And now let me check whether all of you have understood the difference between null hypothesis and alternate hypothesis. Now there is a statement. Please read out the statement and tell me whether it is null or alternate. And also tell me which is X variable and which is Y variable. Come on.
So porosity would be the Y variable over here, and pouring temperature would be the X variable.
Very good. I agree. Now, is this statement a null statement or alternate statement?
Alternate.
Pouring temperature will increase porosity. That means the information is there is an impact. Am I right?
Yes.
There is an impact. Now check whether there is an impact in the statement. Calorie consumption will affect. Again, there is an impact. If you consume more calories, you will become more. You will weigh more. Now, which is X variable? Which is Y variable?
Calorie consumption is the X variable, weight gain is the Y variable.
Very good, fantastic. Speed of the car will affect its mileage.
Mileage is a Y variable, speed of car is X variable, and yeah.
Very good. Now this is null or alternate?
The alternate.
Reaction time. Reaction time will affect the process yield. Again, alternate. Am I right? Reaction time is X variable and the process yield is Y variable. All of them are alternate hypothesis. Hereafter, when you are communicating something, you should know what kind of statement you are communicating. The training will have an impact on your skills. The black belt training you are undergoing will have an impact on your skill set. Now, what is the statement? Null or alternate? Alternate, right? So if you say like if you communicate like it, then there won't be any difference in your abilities, in your skill set before and after training. Then your statement is null, right? So understood. And now I have the opposites of all these statements. So obviously all of them will become now null hypothesis. Look at the statement now. Pouring temperature has no impact on what is that? Porosity. When I talk like this is null hypothesis. Suppose when I talk in this manner, calorie consumption is not responsible for weight gain.
It's a null.
Yes, Satish. Any doubt? So speed of the car will not affect the mileage. Reaction time will not affect the process yield. All these things are statement of no impact. So it is null hypothesis. All of you now understand the clear difference between null hypothesis and alternate hypothesis?
Yes.
Yes.
Now, coming to your business scenario. Now there are two suppliers. And there is, your boss is telling supplier one or your team members are telling, sir, supplier one deliver very fast than supplier two. Now, what is this statement? Is this a null statement or alternate statement?
Alternate.
Great. Alternate. Machine number one can produce parts faster than machine number two.
Alternate, sir.
Alternate.
Polling rate of northern region is more than the southern region.
Again alternate, sir.
Very good. Transaction time of vendors are not same.
It's a null.
Transaction time of vendors are not same. That means different. That means transaction depends on the type of vendor. Alternate, right? You have to be very, very careful. All of them are statement of inequality, alternate. I can always go for the opposite. When I go for the opposite, they will be called null. Am I right? But your hypothesis testing starts with the framing of null hypothesis first. You have to be very, very careful in drafting the null hypothesis, right? So all of you are with me on the null and alternate so far? Yes.
Yes.
This is my first lesson, first part of the session, right? All of you have understood very correctly. So hypothesis testing is basically a decision-making procedure. We take decision on the null hypothesis, all of you. We take decision on the null hypothesis. It is an experimental procedure to test whether the difference observed in the experimental study is a true difference in real life or not. But how to do it? You need to understand about one more tool, which is called p-value. I'll come to that. Null hypothesis is a statement of no impact, statement of equality, statement of no difference. Alternate hypothesis is a statement of impact, statement of inequality, and statement of difference. Null hypothesis is a statement made using the common knowledge. Whatever you have, you know so far, based on that you are talking, that is null. That's innocence. But based on the experiment, what is that you have observed? Now you are making a statement that will be called alternate. Hope the first part is very clear to all of you. Am I right?
Sir. Yes, sir.
Very good. So now we are actually now trying to conduct. An experiment. We are trying to conduct, I'll share the screen again. We are trying to conduct an experiment. Why? Because we want to understand what is happening in our process. So now in order to understand what is happening in our process, is it possible for you to study each and every output that is coming out of your process? Which is called, the full audit. Do you think full audit is an easy job?
No, sir.
Always we believe in sampling, isn't it?
Yes, sir.
Every single shift, I take one sample, or otherwise every single hour I can take one sample. But I cannot go to the extent of doing 100% inspection. Then my company will become an inspection company, right? My job is to produce good product. My job is not checking, checking whether the product is good or bad. My main job is to produce product. So there has to be less of inspection. At the same time, you should be able to understand your process performance, right? So what I'm trying to say is most of the time we depend on sample. And based on what we observe in the sample, we predict about our population. Based on the sample, we predict about our population. Suppose if you make a mistake in sampling, what will happen to your prediction? Prediction will go wrong.
Incorrect.
Prediction will go wrong, right? So this is called sampling risk. Even if you do an experiment, if you make mistakes while conducting the experiment, even your experimental output, the inference from the experimental experiment can also go wrong. So you need to understand that sampling error is possible. You must admit it. Without admitting sampling risk, you should not go for the sampling study. Hypothesis testing is a sampling study. Hypothesis testing is an inferential statistics. There are two types of error possible: type 1 error, type 2 error. And there are two more terms: confidence level and power of test. We will understand. First, let me simplify the job for you, right? So to understand the type 1 and type 2 error, let us consider a manufacturing scenario, right? And in a manufacturing scenario means in the x-axis talks about the reality of the product, the reality of the lot you produced. The lot can be a good lot can be a bad lot. But whether the lot is good or bad, how do you know? By studying a sample. And based on the study based on the, sample studied, you are rejecting a good lot. Is it an error or not? The lot is good, but you checked the sample and concluded that the lot is bad. Now this is actually an error.
Error, sir.
This is error.
Yes, sir.
A good product is rejected or a good lot is rejected based on the sample. And this is called manufacturer's risk, because the product is good, but manufacturer is suffering because of your limitation of the sampling. It is known as alpha. There has to be a limit for alpha. Anytime you do the sampling study, anytime you do an experimentation, first thing you should decide is fix alpha. How much manufacturer's risk is acceptable? Because if I have to eliminate it, then I should do full audit. Full audit is impossible. So I have to live with it. So I'm fixing that. Generally, it is fixed as 5%. When I say alpha is 5%, it simply means I can commit this type 1 error to a maximum of how much? 5%, not more than that. Which means 95% of the time, a good lot must be accepted and should be dispatched to the customer. All of you understand what is the manufacturer's risk here? All of you understand?
Come again, if possible. Can you come again?
See, if I reject a good lot as, the lot is good, but I am rejecting it. Why I am rejecting it? Because my sample is bad. Whatever sample I have taken, that is bad. So now as a result, I am, rejecting a good lot. This is actually an error. The error is called type 1 error. The error is called type 1 error. And there is a limit we always set for this kind of risk. So it is generally fixed at 5%. So alpha is set at 5%, which means the manufacturer's risk permissible manufacturer risk is 5%. When at the moment I fix manufacturer's risk as 5%, my expectation is at least 95% of the time, good lot must be accepted. This is how you have to design your sampling, right? So 1 minus alpha is called confidence level. 1 minus alpha is called confidence level. Let us have another example. Let us say, who asked the question? Rahul, right? Rahul. Yeah, let us say Rahul want to buy a rice bag. Rahul is buying a rice bag for the family. So he is going to a rice merchant and tell me, Rahul, how do you buy a rice bag, a 25 kg rice bag?
So first of all, I'll just go to, I'll check a few grains from that sample, if it is fine or not.
Okay.
And then I will just, based on that sample, I will just decide if I should go for this or not. If the quality is good, then I'll go for that bag.
So here the rice bag is the lot. Rice bag is the lot. Rahul really cannot check each and every grain in the rice bag. Am I correct, Rahul?
Yes, exactly.
So 100% inspection is impossible. So probably Rahul will take a handful of rice and then check. Now this is coming to the same scenario of what we are talking, right? So which is called sampling, taking decision about the lot using a sample. Taking decision about the lot using a sample. And now the sample is actually, sample is looking bad. Sample is looking bad. And so Rahul has decided not to buy. But the new bag of rice, that may be actually good. The sample which Rahul has taken, might not be the real representative of the quality of the rice bag. Possible or not? The sample you picked up may be bad, but all the grains inside the bag may be good. Possibility is there or not?
Yes.
Yes, yes.
That means sampling always comes with the risk. And the industry standard is 5% of risk is livable, tolerable. This is what we call it as alpha. And another possibility is there. Rahul is checking a handful of rice and Rahul is happy with the rice. So he decided to buy the entire lot. So one bag full of rice he purchased and went home happily. And then what will happen in the family, they started cooking the rice. And after cooking, they come to know that, the rice is, having a lot of dust and then stones inside. And now what went wrong? He picked up a sample and sample was good. And he decided to buy the bag. But after bringing the bag to home, during cooking, they come to know that the quality is bad. Possible or not? Now, who is
Yes.
under risk now? Manufacturer or the consumer now?
Consumer.
So both risk are caused by the sampling only. So whenever you take decision about a lot using a sample, you are putting both consumer and the manufacturer under risk. And so there has to be a limit for it. Generally, they are fixed at 5%. Generally, they are fixed at 5%, which means when I say manufacturer risk is 5%, which means 95% of the time, a good lot is accepted as the good only. You have to design your sampling in a way that maybe the number of samples, maybe the sampling technique, which we will be again teaching you, right? Probably in the next week, we will be going deeper into those aspects. So you design them in a way that a good lot is accepted as good lot at least 95% of the time. This is called confidence level. This is called confidence level. So when manufacturer's risk is alpha, confidence level is 1 minus alpha. The manufacturer's risk in hypothesis testing is known as level of significance. Manufacturer's risk in hypothesis testing is known as level of significance, right? And similarly, on the other side, consumer risk. If the consumer risk is 5%, what is consumer risk? Lot is bad, but you are still accepting it. Now, a bad lot is entering the market. You fix it as 5%. That means remaining time, 95% of the time, a bad lot is correctly rejected. This is called power of the test. All of you, do you understand all the 4 terminology I'm using here? Manufacturer's risk, consumer's risk, confidence level, and power of test. Please confirm. All of you, do you understand?
Yes. So, like this manufacturing risk and consumer risk both will come under type 1 error?
No. Manufacturer's risk is type 1 error and consumer's risk is type 2 error.
Okay.
And sometimes the type 1 error is called as false positive and type 2 error is called as false negative. So these are terms. So now let us match the same thing to hypothesis testing. What is our job now? We are validating the statement. And the main statement is null hypothesis. So the reality about the null hypothesis, if our null hypothesis is true, and you have done an experiment and you have rejected the null. Now this is called type 1 error in hypothesis testing. This is called type 1 error in hypothesis testing. So there has to be a limit for it. What is the general limit? 5%. So, but 95% of the time, if you take a decision based on the sample, a true null hypothesis will always get accepted, which is called your confidence level. All of you understand what is confidence level with respect to hypothesis testing? Now on the other side, power of the test, right? So beta risk, the permissible beta risk is, let us say this time permissible beta risk is 10%. So what is the power of test I am targeting? Come on. When I say beta risk, permissible beta risk is 10%, power of the test I am targeting is 90%.
90.
So you need to fix alpha and beta always while conducting the hypothesis testing. And see here, there is an interdependency between your sample size, sampling technique, and the confidence level, power of test, and the statistics you are trying to validate. Statistics means the difference in the statistics. If the difference is more, you can prove the difference with just less sample. But when the difference is less, you may require more samples to prove the difference, right? So this is called alpha risk and beta risk in hypothesis testing. And the permissible and alpha risk is given more importance. And by all means, we have to ensure that the type 1 error is less than 5%. The type 1 error is less than 5%. So always when you are doing an experiment, you should be able to estimate the type 1 error in your experimentation. If the type 1 error in your experimentation is less than 5%, you can believe your experiment. You can believe your experiment. If the type 1 error is more than 5%, it is better not to believe the experiment. It is better not to draw conclusion based on the experiment, right? So that is the suggestion. So tell me, have you understood the second part, all the terminology here? Or any question, please open it for discussion.
Sir, type 2 error, the customer will get bad product.
Yes, type 2 error, customer will get bad product. But yeah, product is bad, but your inspection now will pass the bad product. As a result, a bad product will reach the customer hands, which is called type 2 error. And the permissible consumer risk has to be fixed. Always, whenever you are doing any sampling study, you have to declare, okay, 1% consumer risk is okay for me. And then you should actually design the study in a way that consumer risk is always less than 1%.
Sir, consumer risk is more risk that they will affect. Consumer will affect some.
Correct. You are right. So you have to give a lower value for your beta risk. Keep 1%. Right? If you really wanted to prevent a bad product reaching the customer hands, then you can make it 1%. So what I'm trying to say is you have to fix it. You cannot say, sir, my consumer risk is 0. That you cannot say. Why? Because you are only sampling.
Type 1 error or type 2 error is more risk, more important.
Correct.
Type 2.
But from the manufacturer point of view, type 1 error will affect them. From customer point of view, type 2 error will affect them. We have to take care of both parties. So you can keep 1% for both, or you can keep 5% for both. It all depends on the criticality.
Okay.
All right.
Excuse me, sir. It is possible. It is not mandatory that each value should be equal or more than.
No, not mandatory. It can be different. It can be different. But there has to be an assumption. There has to be a declaration before doing the hypothesis testing.
What type of assumption, sir?
Yeah, you have to declare it. Alpha is 5%.
Okay.
Alpha is 5%. That is you have to declare. Then only the sampling can be designed. Okay. If you don't tell me how much is the alpha, then I can go with any kind of sampling because it is not going to make any sense. Okay. Only when you say, sir, I need a confidence level of 99%. Now I will realize, these people want to be more perfect. Yeah. So let me go with the more sample, right? So always the starting point is declaring alpha.
Yeah.
Right? And similarly, beta. If beta is important, you can declare that also. Okay. And now, how much is the type 1 error in my experimentation? I want to know. For that, there is a beautiful tool called p-value. P-value means probability of significance. Right? And once you understand what this p-value is, you will be able to take effective decision after experimentation. You will be able to understand whether the experimentation is worth interpreting the experimentation or not, right? And now there are 3 definitions I have given. Go through all the 3 definitions and tell me which definition you are able to understand. And we'll start from there.
Second one.
Okay, second one is Arograj. How about others?
The p-value is the risk of observing the data due to a random chance because we are taking samples as randomness, so that only we can conclude that this one is okay.
Okay, I understand Arograj point. Anyone else you would like to differ from Arograj? Others? Are you participating? All others?
Yeah, all seems correct.
No, all are correct. See, which one you find it easy to understand? All are correct only. I have not given anything wrong. All are correct only. Out of the 3, which one you are able to understand easily?
No, only first paragraph, sir.
Second one, sir. Sandeep here, second one.
Second one.
The first one.
First one and second one, right? Can one of you who understood the first one, can you please elaborate for that? Can you please explain? Help me understand in a simple words. What is this? What is this random chance?
It is we can take this rice example that you just explained.
Special cause.
The same thing.
Okay. That means I observed something, but that is not the fact. That is what you are trying to say. Am I right? Random
sir.
means
Yes.
I observed something, but it happened randomly. Nothing significant about it. Say, for example, you are giving the exam. I am asking 100 questions. For all 100 questions, you are giving, you are choosing the option B, option B, option B, option B, option B. Now the final result comes, you have passed the exam. Now you passing the exam is a random chance. Am I right?
Yes.
Possible or not? Sometimes without preparing for the exam also, this kind of MCQ exam, you can simply, do hinky panky and then you can still pass the exam. But what made you to pass the exam? Is it your effort or is it a luck?
Yeah.
Come on, please be interactive.
Luck.
Yeah, it is purely a luck factor. Luck means a random factor. You randomly ticked the answer and you randomly passed. I cannot consider this as, due to your effort. There is a possibility for this kind of thing to happen when you are doing an experimentation also. Am I correct or not? Whatever you observe in the experiment may sometimes be due to a random chance. Agree, all of you?
Yes, sir.
Because for everything there is a chance. Now the challenge is, how can you minimize that chance? How much risk you are okay to take? 5%. So p-value will actually measure what is the probability for an event to happen randomly. If the probability for an event to happen randomly is 5% or less than 5%, all rest of the time, it will happen only if the factor is playing. Right?
To avoid this error, we have to take multiple samples. It may be a chance to get accurate.
Correct. That is the reason why we always go for multiple sample. Because randomly happening once or twice it can happen. But when I take 5 sample and continuously 5 times it happens, it cannot happen by random chance. Isn't it? So that is why we always go for multiple samples. The last statement, p-value is an estimate of the type 1 error you may commit while rejecting the null. Because when you reject a null hypothesis, which is actually correct, which is called type 1 error, right? So you should not reject a correct null hypothesis. So what is the chance, what is the probability or estimate of the type 1 error you may commit while rejecting the null hypothesis? This will appear in a tool called p-value. This will appear in a tool called p-value. If the p-value is known, you understand the estimated type 1 error. If the estimated type 1 error is less than 5%, then the estimated confidence level is more than 95%. Am I correct? If the error is less than 5%, the confidence level in accepting the null is 95%. Right? So that is what we learned, in the previous slides. So ultimately, when you are doing the null hypothesis, you should try to achieve a confidence level of 95% for accepting the null. Right? Similarly, when you are rejecting the null, you make sure the type 1 error is less than 5%. So p-value will capture the type 1 error. So whenever the p-value is less than 0.05, which means less than 5%, that's the time only you should reject the null, because that is the rule of the game, isn't it? That is the rule of the game. First declaration, alpha 0.05, alpha 5%, which means the type 1 error that may happen in your experimentation should be less than 5%. So for that, you require a tool called p-value. But how this tool works, p-value, we will discuss slightly later, right? The calculations behind p-value. But now p-value captures the estimate of the type 1 error. So look at the p-value. Now you understand about the amount of type 1 error. If the type 1 error is less than 5%, yes, confidently reject the null. Confidently rejecting the null means you started ignoring the innocence. You started believing the alternate. The expert's opinion can be true. All of you, do you understand? So, whenever p-value is more than 0.05, don't reject the null. Continue with the belief. What is there in your organization? You just align with them. Don't differ from them. But when the p-value is less than 0.05, you can differ from the organization's belief and you can show them your experiment. But when the p-value is more than 0.05, don't show your experimental results, because your experimental result comes with more than 5% error. So when the experimental result comes with more than 5% of type 1 error, it is not a good practice to use it to defend your claim. So those times we will ignore the experimental study. But whenever the p-value is less than 0.05, we will consider the difference we observe in the experiment as significant. If the difference is significant, then the factor under study is significant factor, which is critical factor, which is root cause. Understood, all of you?
Yes.
Yes. So,
Yes, sir.
anybody would like to summarize, or the other trainers, you would like to add your viewpoint here, because this is the most confusing topic we are discussing. So anybody who can add on, you are most welcome now.
You have said it is most confusing. And then
Yeah,
you
that
have
is
asked
why.
the trainers to clarify.
Yes, yes, yes.
Anyway, unless the participants ask for any doubt, I think there's nothing else to be
We can take
further
it.
explained.
Right. All right. So all of you, do you understand what is that you have learned here so far? I have taught you something in 3 stages. I explained you null and alternate. And then I explained you, what is that? Type 1, type 2 error. Am I right? Type 1, type 2 error. And then what else?
P-value. P-value.
P-value, correct. So
can we say that, sorry to interrupt, can we say that p-value is there is is entirely dependent on like type 1 error, but in this sense that you should always try to avoid the type 1 error, and and in order to and our focus should be, since our focus is to avoid the type 1 error, and so we are assigning the p-value based on that to avoid the type 1 error.
Our focus is on type 1 error. So we always ensure p-value is less than 0.05. But you can also bring the focus on what you call type 2 error also. You can declare that also. Say, for example, you want to have 5% for type 1 error, same 5% for type 2 error. Yes, that is possible. Because these are interdependent. What are the interdependent factors? Type 1 error, type 2 error, and then your sample size. Am I right? Sample size and sampling technique. And then the difference in your statistics. Difference in your statistics. Let us say, before training, I conduct the examination. Your mark is 35. And after training, we are conducting the same exam. The mark is 85. Now my doubt is whether the improvement in the mark is due to the training you have undergone or not. You understand the situation now? Before exam, mark is 35. But after exam, mark is 85. Now how much is the difference in the statistics? Tell me.
50%? 50 marks?
50 marks. Now how many exams are required to conclude that training has significantly improved the performance of the candidate? How many exams you would like to conduct? 1 is enough?
1 should be enough.
1 should be enough. Because the difference is more, 50. Am I right? Sir, no. Suppose if the difference is marginal, let us say, before training program, your mark is 65. After training program, your mark is 67. Now I want to claim the increase in the 2 mark is due to the training you have attended. Do you think now now it is difficult to understand the significance, isn't it? Because the 2 marks increase or decrease can happen randomly also. Am I correct or not?
Yes.
This is what we are trying to understand, whether the difference is actually due to the factor which we are studying or not. Whether the difference is due to the factor or not. So if the difference is small, if you still wanted to climb, you have to go for more experiments. Let us say you conduct the exam for 5 times, and all 5 times, the difference is just 2 marks. Then you can make a climb. But again, still, there is a chance that since the difference is small, there is a chance that it can be merely due to random also. So that is why we increase the sample size sometimes, and we also look at the p-value before drawing conclusion. All right. So, but you have to go through this many times, and then you need to master it so that you can actually, you will clearly understand. See, now
I want to take some time. One more. Can I take?
Yes.
Can I take a second?
Yeah, definitely.
Participants, I just want to give you some more input so that you will remember forever. Right. One is the null hypothesis. You all know what is null hypothesis, right? Somebody says that there is already a claim existing, there is already a belief going on. That is null hypothesis. That means no change is taking place, right? Null hypothesis means what is accepted is generally accepted is null hypothesis. Is it true? Yes or no?
Yes.
Okay.
Sir.
Yes.
Now I am supplying a milk bottle with milk containing 800 grams. I've been supplying for the past 10 years. So my milk bottle will contain 800 grams of milk. That is null hypothesis. Okay?
Yeah.
Yes or no?
Okay.
Right. Now we call this as a positive statement. We call this as a positive statement, right?
Yeah.
Now, suppose I say that I'm saying false. I say I'm saying false means I'm opposing this. No, it is not 800 grams. It is something else. So this is called false positive. What is this called false positive? You are questioning, right? You are not questioning. You are saying that it is wrong. So this is called false positive. Understood? Clear? False positive. Positive is what is correct. So we are saying that false positive. It is not correct, right? So null hypothesis is true, but you are rejecting the null. So when you are rejecting the null, you are making type 1 error. Okay. Type 1 error is called false positive. Type 1 error occurs when you are rejecting the null. Type 1 error occurs when P is less than 0.05. Clear? Understood? These things note down, because when you come across these statements, you should be in a position to talk equally in a jargon way, so that they will, this gentleman knows something. His trainer must be RK. Right? Okay, thank you very much.
P-value is greater than 0.5.
What is that?
If P-value is greater than 0.5, fail to reject it.
Yeah, then you are rejecting. Suppose you are rejecting by mistake, no? Actually, by chance, it has become not less than 0.05 for your case, because you are all based on only one sample, no? You are taking a decision only by one sample now. That sample in a fluke, no, it might be lower than, but normally it is always as per the null hypothesis only. The mean is always as expected only. But in your case, rarely it has happened. So the decision is wrong. That wrong decision, that is called error. That is called type 1 error. Okay.
Sir, can you show me the previous slide of decision rules of P?
Yes, this one.
Yeah, bus adjustments.
P-value is greater than 0.5.
Then you are accepting. There again, you might have made a mistake. There again, you might have made a mistake. That is called type 2 error. False negative. That's all. I did not say all those things because that will be confusing you. Therefore, if you know one thing already, the other one automatically follows. Right?
Yeah.
The other one is type 2 error. That is called false negative. That is when you are accepting a decision. When you are accepting the null. Okay.
Yes, James, you complete your doubt.
Fail to accept the null hypothesis. This is then only p-value is increasing, or fail to reject the null hypothesis.
See, please understand. We are doing hypothesis testing only to take a decision on the null hypothesis.
Okay.
There are two decisions possible. Either I will reject the null or I don't reject the null.
Okay.
What is null always? Null is always an innocence. Everyone in my company is believing something without knowing whether it is correct or not. That is innocence.
Okay.
Right? You are going to break that understanding. For that purpose only you have conducted the experiment. Am I right?
Yes.
Yeah.
Now when you are trying to differ from the old belief, you must have conducted an experiment with the type 1 error of less than 5%. Then only you must rely on your experiment. Then only you should make statement using what you have observed in the experiment. Otherwise, even after conducting the experiment, I suggest you to keep quiet. Do you understand what I'm talking?
Okay.
You have done the experiment. You have noticed some difference. You claim it only when your p-value is less than 5%.
Okay.
Don't claim it when the p-value is more than 5%. Clear? So now read the decision rule. P-value is less than 0.05. Now you can make a claim, isn't it? Now you can differ from the other's opinion. That is why you are proceeding and you are rejecting the null. Hey, hereafter, don't consider temperature as a non-critical factor. No, it is a critical factor.
Okay.
If you are pouring the metal even with the 5 degrees Celsius difference, that will pull down our quality heavily. 400 degrees Celsius means 400 degrees Celsius only. Do you understand?
Understand. So our experiment our output value, the p value is less than 0.05, then we can reject the null.
Exactly.
I got the point.
And like RK was saying, when you are rejecting the null, it means you are accepting the alternate. What is null? Temperature is not critical. Then what is alternate? Temperature is critical.
The p value means our experiment output value, p value. P value we are finding, and the p value is less than 0.5, we can null that hypothesis.
Yes, you can
we
reject
can
that.
reject that null hypothesis. If our output p value is greater than 0.5, we cannot reject that null hypothesis.
Exactly.
I want one thing, sir. Mr.
Yes, sir.
James, you are using the term confusingly. You should not use like that. Output p-value and all you should not use. Output is different, p-value is different. Okay.
P-value is calculated based on the output.
If you speak with output p-value and all, people will laugh at you. Don't do that.
No. They are learning the first time. See, your doubt is correct. P-value is calculated based on your output value. But please understand, we have not taught you how to calculate p-value.
No, sir. That in Minita we will get that p value.
Exactly. But we want to teach you. We will be teaching you slightly at a later stage. Once you digest what is p-value, then we will be showing you how to calculate p-value. Because dumping everything at a time will not make sense. Right?
I am not telling p value is the output. That I am telling that p value we calculated and its value is less than 0.05, then we can reject the null hypothesis.
Correct. Good.
I understood, sir.
Good.
Excuse me, Gopal sir.
Yeah.
Please verify my understanding. If someone can say to me that the temperature can highly affect our pouring process.
Okay. Then
so
it is first of all, it is alternate hypothesis.
So we can say that no, it can't be affected. So after that, we find out the p value. If it will be a less than 0.05, so then we can reject. No, it may be.
What is your statement you said? Temperature?
Temperature is highly affect our process or pouring process.
Temperature affects our process. That is first of all alternate. You derive the null first.
Okay.
Temperature will not affect my process quality. Now that is null. And now look at the p-value. Because p-value is only to take decision on the null. P-value is less than 0.05. You reject the null. Which means temperature is affecting your process quality. Expert's opinion, brainstorming output is really correct.
Okay.
All right. And now there is a case study here. A cooking oil manufacturer, they claim that the fat content in the cooking oil is 15%. The specification that is written on the product is 15%. Now you are a dietitian. You want to recommend the cooking oil to all your clients. And before recommending, you wanted to be sure on the fat content, because fat is something, very important for your client's health. So you wanted to be sure the fat content is really around the 15%, not far away. Really around the 15%, not far away. So what you do is you purchase, let us say, some 10 or 13 bottles of cooking oil from the market. You purchase 10 or 13 cooking oil bottle from the market. After purchasing 13 bottles, what will you do? You will send them to laboratory. Am I right? Yes or no?
Yeah, we will send the laboratory to find
All
out the
13
fat
bottles, all 13 bottles you are sending to laboratory. Now the
Yeah.
lab report comes. The lab report will clearly say the saturated fat content is this much. Now 13 values will be available. Now you have to take a decision. How will you take a decision? Will you look at the maximum value, or will you look at the minimum value, or will you look at the average?
We look at the maximum value.
Oh, you look at the maximum value because
Average.
average is better. But if you are looking at the maximum value, then you want to be more safer. You want to be more
Pardon, sir?
safer.
Pardon, sir?
When you are looking at the maximum value, then by all means you want to increase the power of test. Right? But generally, we use average so that we have a proper balance between power of test, between what you call the confidence level, and all these things. So average. So we calculate the average fat content using the 13 cooking oil bottle. If the average is far higher than 15%, I will not recommend the cooking oil to my clients. Right? For a good health, it should be around 15%. Too less also problem, too high also problem. Then my test is two-tailed test. Suppose sometimes only the right side is the critical for my client, then the test is right-tailed study. Suppose only the left side is critical, then it is called left-tailed study. But how I did the study? I took 13 samples, sent to laboratory. I got 13 data point. With the 13 data point, I calculated average. I can also calculate standard deviation. And then I can use the average and standard deviation to generate p-value. In order to generate p-value, in between, I have to generate something called G-score. Something called G-score. G-score depends on sample average and standard deviation. Sample average, standard deviation, and the target value. Target value is 15%. Target fat content is 15%. But the sample averages can be any value. And standard deviation, there are two standard deviation. One is sample standard deviation, another one is population standard deviation. But if you are a dietitian, you may not know about population standard deviation. You will know only sample standard deviation, right? So now using sample standard deviation, using sample average, you are trying to understand whether the cooking oil bottle have 15% fat content or something different. Now your test is called one sample t-test. Your test is called one sample t-test. When to go for one sample t-test? Your data must be continuous. Can you see fat content? Can you all understand fat content is a continuous data? Am I right? Fat content is measurable?
Measurable, sir.
Measurable. So fat content is continuous data. And you are using average. And you have used only sample characteristics to judge on the population. Only sample characteristics. You are used the sample characteristics to judge on the population characteristics. The study is called one sample t-test. Sometimes, if the company that is manufacturing the cooking oil, if they themselves want to do the study, they can go for G-test because population is known population to them. All of you, do you understand the difference in the scenario? If you are the dietitian, for you, you don't have any clue about the characteristics of the population. All that you have is access to the 13 samples. Am I correct? Yes or no?
Yeah.
You only have access to the sample. You are playing only with the sample. But if you are the quality head inside the company, you can take sample. You can also, refer to the characteristics of the population if the data is available. If data is available, population standard deviation can also be calculated. Population standard deviation, right? Please, all of you need to understand. There are two things I'm speaking here.
Sir, excuse me, sorry to interrupt, but can you just explain this once again? Because even in this sample, the 13 sample cases, I have the data, right? They have printed that this fat is 15%, this much. I have the data, then how can I
See, understand.
cannot understand?
Yeah, see, population means everything the company is producing. According to the company's data, they have declared that fat content is 15%. Every single bottle that the company is producing is expected to have a fat content of 15%. The expected value is nothing but average value. So all of you understand about it, right? Know about it. Expected value is nothing but average. Only the average you can expect. Right? Yeah. So this is the average. According to the company, there will be a population standard deviation, which is called as sigma. What is population standard deviation? The company might have produced, let us say 10,000 cooking oil bottle. Now 10,000 data will be available. With all 10,000 data, if you calculate a standard deviation, that is called population standard deviation. All of you, do you understand what is population average and population standard deviation? Population average is this one. We use a symbol called mu. We use a symbol called mu for population average. And for population standard deviation, what is the symbol? Sigma. But now you only have sample. With the sample, you are trying to judge on the mu. Sample will only have sample average. Am I right? Which is X bar. Am I correct or not?
Yes.
Sample average is called X bar.
Yes, sir.
And sample will also have a standard deviation, which is called S. At occasion, you might have only S. At times, you may also have idea about sigma. Suppose if your company is telling you, hey, our population standard deviation is this much. When population standard deviation is known to you, is given to you, go for the G test. If population standard deviation is not given to you, what is the alternate you have? You only have sample standard deviation. Under that situation, you should go for t-test. So this is the difference in scenario between t-test and g-test. But in both cases, the test is called one sample test. It can be either one sample t-test or it can be one sample g-test. All of you understand? Yes?
Yes.
Very good. And now let us consider another scenario. Now there are two vendors supplying providing support to your company. You have contract with the two vendors because your company believes that both of them can perform almost at the same level. Am I correct?
Yeah.
So null hypothesis says the performance is same. And in order to measure the performance, I am considering the factor transaction time. Transaction time of the vendor A is equal to transaction time of the vendor B. Now, what is the statement? Null statement. Null statement. Transaction time of vendor A is equal to vendor B. But ultimately, I wanted to find out whether a difference exists. If a difference exists, whichever vendor is performing better, I will work with them, and the other person, I will disconnect the contract. Now you are comparing one vendor against another vendor. Vendor A transaction time is available. Vendor B transaction time is available. Let us say for past 1 month. The average transaction time of vendor A available, average transaction time of vendor B available. Here there is no question of population at all. It is vendor A, vendor B. Sample A, sample B. The test is called a two-sample t-test. Here also the transaction time is measurable data, continuous data. Here also for taking the decision, I am using average transaction time. All of you understand when to go for two-sample t-test? Yes. For comparing a cooking oil against the population, We have gone for one sample G test or one sample T test. Suppose if there are two companies making cooking oil by company A and cooking oil B. I am comparing A and B. Now my test will be called two sample T test. All of you, do you understand? There are two companies, both of them are claiming the fat content is 15%. Now I want to understand whether a difference exists between the two brands. Are they really equal, or is there any one is inferior and the other one is superior? And the characteristics I am checking is again fat content. Since I am comparing two samples, the study is called two sample T test. In the place of two, I can have three. Third company also now comes, third brand, or the third vendor comes. Now the study will now be called ANOVA. Now the study will be called ANOVA. And today, Pakistan and England, they are playing in the cricket final, isn't it? T20 final.
Yeah.
That is also a hypothesis testing. Before the match, the belief is both teams are equal. Am I right? Before the match, before start of the match, what is the belief?
Both are on same page.
Both are equally competent. But today evening, we come to know who is the winner. So this is also a hypothesis testing. What is this hypothesis testing? How do you measure the ability of the team? Based on the runs scored. Based on the runs scored in the experiment. Experiment is today's match. Experiment is today's match. Number of runs scored is a continuous data. You are comparing Pakistan against England. What is that test called? Two sample T test.
Okay.
Every decision we take is actually a hypothesis testing. Sometimes we take decision using average. Sometimes we take decision using proportion. You know there is a difference between average and proportion. Can one of you answer me? What is the difference between average and proportion? Now there are 20 students attending the course. Out of the 20, 15 students qualify for the certification. Now what is the success rate of the training program?
25.
75.
75%. This 75%, is it proportion or average?
It's average, exact number. Average.
This is not average.
This is promotion, sir.
Proportion. 15 out of
Because
20.
they passed out the exam, so they went to next level.
Okay.
Exactly. 15 out of 20 is proportion.
Okay.
But if I consider all your test mark and calculate your average test mark, now I am looking at average. Do you understand the difference between average and proportion?
Anything is calculated with the data, what the value we are getting, that is nothing but a average.
Very good. Anything which is measurable, you actually measure and then take the average. Yes, no, you can go for G test, T test, and two sample T test and ANOVA. But sometimes what happens, you depend on countable data. For example, 15 students have passed the exam. How do I know it is 15? I simply counted the passed student. Measurable, we calculate average. Countable, we calculate proportion. Right? Countable means discrete data. When data is continuous, we calculate average. When data is discrete, we calculate proportion. When you are taking decision using the statistics called average, your test can either be G test or one sample T test or two sample T test or ANOVA. When will I go for one sample T test? When population standard deviation is known. When population standard deviation is unknown, I will go for one sample T test. When I am comparing two groups based on the average, what is my test called? Two sample T test. When I am comparing more than two groups at a time and I use average for my decision making, my test is called ANOVA. All of you, do you understand 4 hypothesis testing I have introduced? All of them, the decision is taken using the average. The statistics used is average. Why did I use average? Because my data is continuous data. All of you understand the 4 tests?
Yeah.
Yes or no?
Sir.
Very good. Similarly, instead of average, certain times you may have to take decision using proportion. Let us say the buying power of male and female you are studying, or the not buying power, the buying rate. Whether male are buying more or female are buying more. Or the
Female are
buying decision,
female
right?
are-
Generally in a garment shop, like not garment, let's say the textile showroom, who will generally buy more, or the buying decision, who will be taking the buying decision more frequently than the other, male or female?
Female.
Okay, right? So you have a confusion. So what you do, you conduct an experiment and find out of 100 people, how many male are buying. Similarly, out of 100 female, how many female are actually making a purchase. Now you are taking a decision with the help of the proportion of the people who actually made purchase. You are comparing proportion of male against proportion of female. This is called two proportion test. All of you understand? Yes. This is called two proportion tests. All of you understand or not?
Yes, sir.
Suppose you have three groups, not just two groups, male and female. Now you have company A, or you've got three offices: north office, south office, and then there is an office called west also. So north, south, and west. You have got three offices. You are measuring the performance of your office based on the percentage defectives. Tell me, percentage defective, is it average or proportion? Percentage defective, what is it?
Average, sir.
Let us say in your company, 5% of the items are rejected. Is that 5% is average, or 5 out of 100 is getting rejected?
5 out of 100 is rejected. Remaining is promotion.
That means it is proportion. 5% rejection means you are talking about proportion.
Yes.
The average fat content means you are talking about average. You have to understand, the difference between average and proportion, because hypothesis testings are developed based on the statistics you are using. Average is a statistics, proportion is a statistics. If you use proportion to compare two groups, your study is called a two proportion test.
Right, sir. Understand.
If you use proportion to compare more than two groups, the study is called chi-square test.
Sir,
the study is
pardon?
called chi-square test.
Pardon, sir?
Chi-square. More
More
than two groups. More than two groups.
Okay.
Let us say in the World Cup, there are so many bowlers, right? How many bowlers are there? 30, 40 bowlers are there.
Yeah.
Now, out of the 30, 40 bowler, one bowler is considered, the bowler of the tournament.
Yeah.
And in order to declare the bowler of the tournament, you are counting the number of wickets taken. What is the addition criteria? Number of wickets taken.
Yeah.
Totally 10 matches played. 10 matches played means 100 wickets taken. Assumption. Out of 100 wickets, whoever has taken more wickets, he is going to be declared as the bowler of the match. This is called chi-square test. Because the proportion of wickets I have taken is significantly higher than anyone else. So, a particular bowler is declared the bowler of the tournament. All of you, do you understand?
Yes.
So, proportion.
Can you come again, please?
You have proportion on one side, you have average on other side. You can compare two groups based using average, or you can compare two groups using proportion. It is up to you, depending on the scenario. When you go through the examples, you will be able to understand. For average, we have one sample T, two sample T, and ANOVA. For proportion, we have one proportion, two proportion, and chi-square. One proportion means a sample is compared against reference.
So the basic difference of chi and ANOVA test is average on proportion.
Exactly, that's all, you got the point.
Yeah.
Right?
Because all three depends on three factors. The only difference is between one is calculated on the average and other is something.
Very good. So that's all. This is what I actually want all of you to understand. That means you are now ready to discuss several case studies. and one by one, starting with the G test and other things. See here, the summary is available. You can leisurely go through. See here, there is test of mean. There is test of mean. There is test of variance. There is test of proportion. I have taught you test of mean and test of proportion. Test of mean, what are all there in the right side? Can one of you read out? What are the tests available here, right side?
One sample is a test.
Okay.
One sample t-test.
Okay.
Two sample t-test. ANOVA.
Very good. All the tests, decision is taken using average. In all the tests, data type must be continuous. And for G test, population standard deviation should be known. And now coming to the third portion, test of proportion. What are the tests available?
One portion, two portion, chi-square test.
Proportion. One proportion, two proportion, chi-square. One proportion means you are comparing a sample against a reference. Two proportion means you are comparing a sample against another sample. Machine number 1 compared against machine number 2. Team A compared against team B. Team A success rate is 90%. Team B success rate is 80%. Now team A is given more increment. Now we compared two teams based on the success rate. Success rate is a proportion, right? Chi-square, more than 2 groups is chi-square. Similarly, you can compare 2 groups for variance also. If you say if you are comparing variance of one group against variance of another group, the test is called F test. If there are more than 2 groups, you can still test the variance using any one of the two, Bartlett or Levin. So you just have to know that so many testings exist. But ultimately, why all these tests exist? Because we wanted to take the right decision. We don't want to go wrong, right? Every test will finally produce p-value. Test of mean will produce G score. Test of proportion will produce some characteristics like chi-square. So, finally everything will be converted into p-value and we will take a decision. And ultimately, finally, you can also study the relationship between X variable and Y variable, which is known as correlation and regression analysis, right? So this is what actually I wanted to bring it to your understanding, and so that you can actually now proceed with some case studies, right? So now you are ready to do some hypothesis testing using data and case studies. So that's it from me. I think all rest will be taken care by Vinod Shankar and RK. See, please understand the session, even I also felt...
I'm just copying it to Minitab so that okay. So I'm going to share my screen. Okay, so this is Minitab screen. I want to show you Excel sheet. Right, you have been shared all this Excel sheet. Anybody could open this, or you want to just observe now and do it later? What do you want to do? If you want to copy, you can just copy it and paste onto your Minitab, and you can do parallelly with me, or you can just watch it and see the video later, right? So that we can save the time, right? So I'm going to show you some examples with mean, right? Average, some Z test, T test, 2T test, and one-way ANOVA, right? So that we are going to do. So before that, I am going to explain you what is the data we are going to process and how we are going to conclude, right? So here, this is a one data is for a company's, let us say maybe administrative office, right? Okay, so you can see here there is a claim number. All of you are able to see my Excel sheet?
Yes.
So this is the bill number. Okay, so this is the actual case study. The case study, there are some bill numbers are given here, right? And this is the employee code, right? And these are all the zones: south, east, north, and west, right? There are zones. So there are employees from all the 4 zones, and they are claiming certain bills. Okay, so generally happens. The employees belong to different zones: south, east, north, and west. They are claiming certain bills. Those bills are medical bill and travel bill. Okay, 2 kind of bills they are claiming. One is medical bill, the another one is travel bill. So 2 kind of bills they are claiming. Okay. Now, when the bill is received, it is received on October 2019. And when it is approved, it is 15th October. So how many days? The bill number 1. The bill number medical bill, employee belonging to South is submitting, and it is approved by the authority. 1st October it is received, 15th October it is approved. So how many days are there?
14.
14,
14 days.
14 days, right? Now the bill is approved. Now he has to get the money, right? He has to get the money, right? So when he got the money on 21st October, he got the money, right? So on 1st he has submitted the bill, but he got the money on 21st, right? So how many days it took for him to get the money?
20
days.
20 days, right? Similar to that, employee number 2, he is submitting October 1st. It gets approved on 8th October. That means 7 days it took for approval, right? And he is getting the money on 10th October. So how many days it took for him?
9 days.
9 days. Like that, there are some 100 bills are here, right? For 1 month, right? So this is the case we are going to study, right? This is the case we are going to study, right? So the other things are not required. There are some, what is the amount and what is the delay for why it is delayed, who is the accounts officer, when it is paid, all these details are there, right? So those things is not required for our study. We require only few data from here. So these are full data from the office, right? From here, we will take a few data. This is just to the background I told you. This much data is not required. In that certain data is required. That with that we'll do some exercise in Minitab, right? So that I have just summarized here, right? So we want the zone south, east, north, and west. The employees belong to different zones, and the type of bills. One is medical bill, the other one is travel bill. And how many days it took to approve? 14 days, or how many days it took to pay? 20 days. Like that, for each employee belonging to certain zone, their medical and travel, how many days it took for approval, how many days it took for payment, right? This is only data required for us, and this data we'll use for our study, right? So this data I'm going to copy and paste into my Minitab, right? This much data I'm going to put it into my Minitab, right? If you have got your Minitab ready, you can also copy and paste. This much data is required. We require a data from zone, type, days to approve, and days to pay. This much data is required, right? Okay, so I'm going to copy and paste into my Minitab file, right? So Minitab, you can see that there is zone, type means medical and travel, then days to approve and days to pay. So this much data is required for our study. Is it okay, everyone? Or you want this background is clear? It's a simple office. It's just simple office document, right? So it is generally we do it in our office. So there is nothing special in this. Okay. Now we want to study one by one, right? Now the first question is that there is a suspicion. Okay, there is a suspicion that the days to approve is more than 19 days. The average days to approve, is more than 19 days with a standard deviation of 3.5. So I'll write the suspicion statement. There is a suspicion that the average days to approve is more than 19 days, right? With there's a standard deviation available, the standard deviation of 3.5, right? So this is the suspicion, right? So there is a suspicion that the average days to approve is more than 19 days. Now we want to test that whether this claim is correct or not. So whenever you are doing a hypothesis testing, that was we were discussing till now. First, there should be a null hypothesis. There is a null hypothesis, right? It is also called HO, right?
Yeah.
HO. Yeah. So what should be HO here? The average days to approve is equal to or
Greater than.
Here less than. Either suspicion statement is greater.
Yeah.
So your null statement should be less than.
Less
Equal to
than.
or less than. You can put
Okay.
equal to alone or equal to and less than 19 days. Right? Okay. So this should be the first statement. Right? Then you should write, and the next one is that alternate hypothesis. Alternate hypothesis. So what is alternate hypothesis? Similar to that. The average days to approve is more than
19 days.
19 days, right? So this is your
Alternative
hypothesis. Third thing is that choose the test. Which is the test applicable here? Choose the test. Which is the you have been given, you have to check the average or the mean with a standard deviation given, with a historical standard deviation given. So from your early discussion, what was the appropriate test here? One sample Z test, right? All of you are agreeing?
One sample Z test. Yes, sir.
Yes, because here we are testing 1 days to approve. This column we are testing against a specified value. What is that specified value?
19 days.
19 days, right? And in this case, we have been given a standard deviation, historical standard deviation, right? So in this case, we have to do a test which is called one sample Z test. Is it clear, everyone?
Yes.
So far, it's okay, everyone. Venkata Krishnan and everyone, Jismon, James, everybody is okay?
Yes.
Okay, fine. Whenever feel uncomfortable, just tell me to stop. I'll stop and re-explain. Right? If you don't respond, I will keep on talking. Right? Okay. Now we have to go to our test in the mini tab. Right? So you can watch here, and later also you can see in the video. Right? So here, those who has not seen the mini tab earlier, they can. For them, I'm just explaining. This is area called worksheet. So all the data should be entered here, and this is the area where your output will come. Means the result will come. P-value, all these things will come in this area. This area called session window, right? This is very similar to Excel sheet, but this is not a substitute for Excel sheet, right? Here only statistical analysis only will be done using Minitab, right? Now here one more advantage with this Minitab is that you most of the around 90% of your application is this title called stat. You can see the stat. Stat. This is the area that 90% of the stat and graph. This is the only two area the entire the people who do analysis, they will use. The other things are more or less like an Excel sheet only, right? So stat and graph, this is the two things we have to always look into, right? So in the stat itself, there are so many tests. I also know only 10% of it. So that many things are there available in this, right? So we'll look in this one. So we have to go to stat. And there are some basic statistics. The first title is basic statistics. Now here you can see one sample set test. You are able to see one sample set. Yes or no?
Yes.
Yeah. What is written there? Can anyone read?
Sample Z determine whether the mean of a sample differs significantly.
One second. Differs.
Sample Z determine whether the mean of a sample differs significantly from a specified value when the population standard deviation is known.
Yes. So everything is there. Whether your sample is differing significantly from a specified value. So what is the specified value here? In our case,
19 days.
19. And what is the population standard deviation?
3.5.
3.5, right? So we have to just enter all those things, right? So here, what is the days to approve? So you have to just click days to approve, right? Then J select. And our standard deviation, what is the non-standard deviation? 3.5, right? So 3.5, right? Now here we have to do a hypothesis testing, right? So what is the hypothesized mean? It is 19. 19, right? Now we are going to option. The option is that the mean is greater than hypothesis mean. This is our this is the alternate hypothesis. The mean is greater than hypothesis mean. It is more than 19, right? Now at 95% confidence level, right? So this is everything is clear. Now you have to say okay and okay. Now you can see here what all the things you can see here. This is one sample set test. We want to test whether it is equal or less than 19 versus more than 19, right? And we have got a standard deviation which is 3.5. So everything is clear. 19 days, 3.5. And here it is them other things are given. Like this is how many samples we have tested. There are 100 samples, right? There are 100 samples are available. You can see 100 samples are there, right? 100 samples, right? And mean value 13.42. Sorry, 13.42. Standard deviation is given here, right? Then this is standard error of mean and lower bound. These things we will discuss a little later because this is talking about the here it is a lower tail test. Okay, here what testing we are doing is the lower tail test, right? There is a two tail test, there is one tail test, right? So here we are testing on the lower side, right? Whether it is more than 90 days, that means we are testing on the less than 90 days we are testing, right? Whether it is equal or less than 90 days we are testing, right? So that is given here. So that is what is the 95% confidence level given and Z value. Okay, and the P value. But here our most interested thing is what is the most interested thing in our hypothesis testing, what we were discussing? P value, right? The P value is the value which you will determine you whether your null has to be rejected or alternate has to be rejected. Okay, so that is what we were discussing for half an hour. What is the P value? Okay, so this P value, what is the P value you are finding here?
1.
Right. So now what is the next is that conclusion. What is the conclusion? What is the inference here? Let us say. So what is the condition? If the P value is
less than 0.5, we can accept it.
Is less than 0.05.
Then reject the null.
We have to reject the null. Reject the null. This is our conclusion. But now, if the P value is more than 0.5, what should be the condition?
Reject the alternate hypothesis.
Reject the alternate hypothesis. So here we are always testing our null, right? We are always testing our null. So the decision is on null. Decision is not on alternate, right? Correct. So here what we have to do, since the P value is more than 0.5, we have to accept or reject.
Accept the null.
We have to accept the null, right? If you have to accept the null means automatically what is the meaning? We have to
We
reject the
it.
alternate. Reject the alternate, right? I will do one more one or more examples. You will get clarified. Whoever is having little vague understanding, you will get more clarity. One or two more examples if you do, right? Now there is one more catch here. Even though the word is correct only, but generally, it will be told that we fail to reject the null. Okay, we fail to reject the null. Even though the meaning remains same, but it is the normally this is how the terminology, technical term. What is it? We fail to reject the null. Okay, even though the meaning is we accept the null, but the statement is that we fail to reject the null because of lack of evidence, we cannot tell this person is a convict, right? So in the court also they'll say that because of lack of evidence, we are leaving him, releasing him without any considering him that he is not guilty, right? Because lack of evidence. Similar to that, we fail to reject the null. Why? Because we don't have sufficient evidence to prove that the null is correct and the null is wrong, right? So even though meaning is same, we accept the null. Normally when we write, you should write like we fail to reject the null. Either we reject the null or we fail to reject the null. Clear? Clear, everyone? Okay. Yes or no?
Yes.
Okay, fine. Everybody is okay?
Sir, does this mean if for another alternate hypothesis statement, we can reject the null?
If your p-value is less than 0.5, we have to reject the null. If the p-value is more than 0.5, we fail to reject the null. Very simple.
So if we take another set of
another example, we'll take another example, right? We'll take some other examples and we'll see that how it works, right? Maybe we'll have some more examples, right? Don't worry, we'll see all kind of things, right? In one way or somewhere it will be there. I don't know the even next one also. Now let us see. There is a claim that the average days to pay, right? Now we talked about approve, right? The average days to pay is more than 90 days. There is no standard deviation available here. So now there is another suspicion. What is the suspicion? The average days to pay is more than 90 days, right? So what is the suspicion? The days to pay. First we talked about approve. Now we are discussing about days to pay, right? Days to pay, okay. Now let us see that. So what will be the null hypothesis here? Right? The average days to pay is equal to or less than 19 days, right? Right. Okay. Sorry. Now, and what will be the alternate?
Average is to pay is more than 90 days.
Pay is more than 90 days, right? Okay, is more than 90 days. So what will be the appropriate test? What is the next step? We have to do choose the appropriate test. Which is the test we have to do now?
Also one sample Z test.
One sample Z test. What is the condition?
T test.
Now, somebody told one sample Z test. What is the condition for one sample Z test?
Sample mean standard deviation should.
Standard deviation, population standard deviation should know, right? But in this case, we don't have any standard deviation available. Okay. In this case, no standard deviation available. Then we have to go for another test, which is called a one sample T test.
T test.
Right. Okay. So we have to go for some. So that is the difference between one sample T test and one sample Z test. Right. Yeah. Now, normally one sample T test will have a lesser sample size, and Z test will be having more sample size. But that and some because that is how generally. Okay, T test will, if you have a lesser sample size, you can go for T test, right? If it is more than 30, there is no difference between T test and Z test. Because more than 30, the standard deviation will be considered as population standard deviation, right? But so that is just, your knowledge sake, I told. But generally, if you don't have standard deviation, population standard deviation, you have to go for one sample T test, right? Just keep in mind, the standard deviation is not one sample Z test. When the standard deviation is not one sample T test, right? Now we'll do one sample T test. Okay, so far it's okay, everyone. Why I have chosen one sample T test? Everybody is okay.
Yes, sir. Yes.
Everyone, okay. Okay. Some people are not talking in this. Neha Kumari is not at all talking. Satish is there. Satish Gade, Agilan Shankar. All are there available?
Yes, sir.
So just
Sir,
you also.
sir,
You,
excuse me,
Yeah,
sir.
yeah.
Yes, sir. Please use one sample t-test on this Minitab.
I am showing.
Oh,
One sample. That
yes.
is what I am next time do. See, first before doing Minitab test, you have to first of all write your null,
Yeah.
write your alternate, choose the test, then you have to do. Okay, you cannot do straight away jump into your conclusions.
Yeah. So
So
how to do?
always,
Sir, how to
on,
do this? Please once again, how to do?
what is the T test or Z test? What is your asking?
Yes.
T-test.
T-test. T-test.
I have not started. I have not done at all. I am going to show you. Okay.
Okay.
I have not completed. Where p values are not come, we are not concluded anything. I am going to just tell you. I am just telling you the background behind sample T, one sample T test. Right.
Okay.
We will do now. Okay. Basic statistics.
Yeah.
One sample T test.
Okay.
Can anyone read what is this?
Determine whether the means of a sample differ significantly from a specified value.
What is the specified value here?
Specified value is 19 days.
19. But here standard deviation is not given.
Not
right?
given. Yeah.
When you are done one sample Z test, when you are done, it is very clearly written. Provided your population standard deviation is known. But in this T test, you can see it is not there. Only specified value, right?
Okay.
So then you have to go for sample T test, right? There is no specified value at all, right? Now let us do that one, right? So which one we have to see? Which one
Days to pay. Days to pay.
Days to pay. So days to pay, I have clicked it. I just said select. Then here there is a you want to do or you want to don't want to. So we want to do. So hypothesis testing. The hypothesis mean is 19. Now options. There is an option not equal to, but here we wanted to know more than that, right? That is what is our requirement. So more than 90, that is what is our suspicion, huh? More than 90 days. So I am putting more than 90 days, right? So you have got three options: less than, not equal to, and more than. But in our case, our more than I have chosen because that is our statement, right? Okay, and okay. Now what is the p-value? What you have to look into? Our interest, this one is what is that in our interest? P, right? Now what is the p-value?
0.006.
0.006.
So what is the conclusion? What is the conclusion?
Reject the null. Reject the null.
If the p-value is less than
0.05,
we reject the null, right? So what we have to write? We reject the
null,
right? Or we accept the alternate. In the other conclusion is that means it takes more than 90 days. We reject null. So somebody their claim is correct. It takes more time, more than 90 days it takes. So that is what is the conclusion, huh? Right? Correct?
Yes.
These people, whatever they are thinking, whether they are taking more than 90 days, that suspicion has now confirmed. Yes, it takes more than 90 days. The previous case, there was a suspicion that it is taking more than 90 days for approval. It is not correct. But this suspicion has become okay. Everybody is okay with this so far?
Yes, sir. Yes, sir.
Sir,
all of you are okay? All of you are okay?
Yes, sir.
Okay.
Yadav.
Yes, sir. I am okay. Yes, sir.
Chanchalesh Yadav is okay.
You are one of the person who pronounce right.
Chanchalesh. Oh,
yeah,
okay.
Okay.
बाकी सब ऐसे ही होता है ना? ठीक है. नेहा कुमारी.
Yes, sir.
Okay, I never heard your sound. Thank you. Okay. Now let us go to the next. Everybody is okay with the one sample Z test and one sample T test. What is the next test we have to do? What are all the tests we have learned?
One sample Z test and T test.
T test. What is the next? Anybody written anything?
Two sample.
Two sample T test, right?
Yes.
Now, we'll go for two sample T test, right? So first we have to write the suspicion statement. So there is a suspicion that, so you can see there are two kind of bills. What are all the bills? What are
Medical
the
and
Medical
travel.
and travel.
travel. Okay. Now there is a confusion. There is a what do you call? There is a suspicion that whether the medical and travel bills are not equal. The days to pay, average days to pay medical and average days to pay travel are not equal. This is their what is that? Their suspicion. So the suspicion statement will be the average days to pay medical is not equal to average to pay travel. Right? Is correct? There is a suspicion. Average days to pay for medical is not equal to average days to pay travel. Right? So the null will be
is equal.
Average days to pay
Medical is equal to
average days to pay
travel.
Right? Okay, average days to pay travel. Right. Now what is the alternate? They are not equal.
Not equal.
Okay. To pay medical is not equal to. So I'm just writing is not equal to. Is not equal to. Sorry. Average days to pay travel. Right. Okay. Now what is the next step in this?
Choose the test.
You have to choose the test. To sample T test. Right. Now everything is okay. Now what I have to do? I have to just compare these two, right, with reference to days to pay. So let us see what you can do. So go to stat and basic statistics. One sample, two sample T tests, right? So what is given here?
Yes.
Determine whether the mean differs significantly between two groups. Correct? All of you are able to see?
Okay. Yes, sir.
Determine whether the mean differs significantly between the two groups.
Two groups. Which are all the groups here now?
Medical and travel.
Medical and travel.
Medical and travel are two groups. So whether they are significantly different, right? Significantly means meaningfully different, right? So let us just do that.
Yeah.
Samples are lying in our days to pay, right? So days to pay, right? Now sample ID is lying in type, right? So that is a type. Type in this column it is available, right? So
Yeah.
select, right? Now here maybe you can take a graph also. In this case, I'll put a graph also. So graph also we can see how graph looks like. And there is an option, right? Here there is no more than or less than. Here it is not equal because our alternate hypothesis says that they are not equal, right? That's what is our alternate hypothesis saying. The suspicion statement says that only, right? They are not equal, right? We are suspecting that travel and medical are not equal, right? Either one we say more or other one is less. Okay, either case, right? So I am going to choose that as my alternate hypothesis, right? Everybody is clear?
Yes, sir.
Okay. And confidence level again 95%. Generally, most of the cases the 95% it will be 95% confidence level, right? Okay, that is how the 5% of p value we are considering, right? Now I am saying okay. Hello, it has come. Now some graph you are able to see. Now by looking into the graph, these are all the days to pay. 10 days, 15 days, 20, 25, 30, 35 days. The days is given in the y-axis. And there are two groups. Group 1 is medical, group 2 is travel. Now, by looking into this graph, can anyone say that which is better, which is taking more time by looking into the graph?
Medical.
Medical takes more time. How much time it takes? Let us just go and keep it here. So it is showing 20.75, right? Whereas travel it takes 19.5, right? Now, by looking into the graph, can we say that whether it is significantly different or not? By looking into the graph, can anyone say whether it is really significantly different or is just?
Yes, sir.
It is significantly different. How many of you feel that it is significantly different?
No, very fractionally different. Not very.
Just 1 point.
1 point. But how do you conclude? These are all our assumption. These are all our assumptions. It's for me, it may be, I'll tell that there is a significant difference. But maybe Venkat Krishnan will say that, no, it is not significant. For me, it is fraction. Right? Or somebody else will say that, no, it is, James will say that, it is significantly different. But how will you conclude? Just by looking into graph, can we conclude by looking into graph and conclude? Then there will be a dispute.
No, sir. We should know the p-value.
You have to look into p-value,
Yeah.
right? The graph will tell you some idea that which is more or which is less, right?
Yeah.
It will give you some sort of visual conclusion, but it is not the final conclusion, just a apparent conclusion, right? It is not the final conclusion, right? Okay, so for that you have to look into the graph. Sorry, p-value. So let us come to the p-value. What is the p-value here?
0.17.
0.17. 0.17 is the p-value. So what is your conclusion now?
0.17.
You have to accept the alternate
More than
hypothesis.
0.05, fail to reject the null.
You have to accept the null.
We have to accept the null. So in other words, there is no difference.
Except
We fail to reject the null. That means
both are almost equal.
We fail to reject the null. Yes, fantastic. Now I think you are all got into the correct group, right? So we fail to reject the null means there is no difference. There is difference, but it's significantly there is no difference. Now, if you really want to see into looking into graph very slightly more, this is just random. Okay, after if you take the November data, this may be the reverse also. There is a marginal difference, right? So this is what is called a two-way. This is called a two-T test. Two sample t-test, right? Okay, now we have to go to the next one, right? The next one I'll change let me see. The next one we'll change a different. Here also we can do it. Maybe first we will do some different test. Then if you want, we can do here also. Two type we will do. What is the next test we want to do? What is the next in your list for average?
ANOVA test.
One-way ANOVA test, right? It is called a one-way ANOVA.
One-way.
Right, one-way ANOVA. Right. Now I am going to slightly change the subject from your medical and all these things. Maybe we can do one experiment here also, but we will just I'm slightly changing to a new scenario because maybe you must have got bored with this medical and claiming and all. Okay, I'm slightly changing the topic. Right. Topic means the subject case study. Right. Here you can see 4 machines. Machine A, machine B, machine C, machine D. You can see this.
Yeah.
This is machine A, B, C, D, right? These 4 machines are giving certain output. Okay, that output they wanted to test some load. Load means force. Okay, the output of the machine has got a critical quality that it has to meet a certain load, right? Certain load is the critical to quality for that particular machine, right? So machine A is having, there are some readings for machine A. Then machine B, when we take some samples have taken, the readings have come here. Machine C and finally machine D, right? Now I want to test that whether these machines are giving me the same output, same CTQ, same average value, by produced by all the 4 machines, right? This I wanted to see. right? Or I want to test that is there any machine is significantly different from the other, or all the four machines are different from each other, or two machines are different from the other two machines. Okay, I want to test that whether machines are different from each other or not, or at least one of them is different from each other or not. Okay, so this is what is the case study we are going to do, one way ANOVA. Why it is one way ANOVA? Why it is called ANOVA test?
Yeah, conduct the test within one.
More than
Sorry.
two.
Yeah, more than two.
Yeah. So we are going to do the test of averages of the groups, which are, if it is only one group, then one sample t test. If there are two groups, then it is two sample t test. But here we are going to test more than two. So when the number of tests in terms of average is, if it is more than two groups, then we have to choose a test which is called ANOVA, one way ANOVA. So where one way ANOVA is used, everybody is clear?
Yes.
Everybody is clear?
The group is more than two, you have to choose ANOVA test.
Yes. But all others, Venkatakrishnan,
Yes, sir.
Satish, everybody is clear. Agilan Shankar, okay? Agilan?
Yeah.
Okay, everybody is okay. Jismon, James, okay?
Yes, sir.
Okay, all of you are clear, right? Now, so this is what we are going to do. We can do is here also we can do it south, east, north, west. Any of them are for days to pay is significantly different or not, that we can do here also. But this will give you p value more than 0.5, so it doesn't give much significance. We wanted to see that if the p value is less than 0.5, how to interpret. That is more interesting, right? That's why I have chosen this one, right? Later, if you want to see something with this, that also I can show you, right? So let us see that. But now there is some conditions for one way ANOVA. So before doing one way ANOVA, there are some conditions applicable, right? One is that the data should be normal. Do you know what is the normality test? Do you know what is normality?
Normality, it occurs, it means that the normal distribution curve, I think.
Right. Yeah, you're right. So others, normality, the normal test means the data follows a normal distribution, right? Generally, if the data follows a normal distribution, your prediction will be very good, right? If the data doesn't follow, still you can do it, but then your the prediction will be maybe erroneous, right? So it is always better that we have to meet all these assumptions, right? So the first assumption is that the data should be normal, right? So for that there is a test available. So stat basic statistics, there is a normality test you can see here. Determine whether your data follow a normal distribution, right? And for a continuous measurement, such as length, weight, all those things, right? So normality test. We'll do for one. Okay. Any one machine. Tell me any one or two machine. Which machine we want to test? Tell me. All we have to do it, but because of lack of time, I'll show you one or two, right? Which machine? Your choice.
We have to take A and D.
A and D you want to see? Okay. I'm seeing first A. All the four we require, but because here lack of time, I'm just putting one or two, right? Just say select machine A and say okay. Now the p value, how much it is?
0.721.
0.721 means the data is normal, right? If it is less than 0.5 means the data is not normal. So that is the case for machine A, right? Now we have to do it for all the machine. Stat, basic statistics, normality test. Any one machine, any more machine, D will do. We'll do D also. Okay. So what is the p value?
0.795.
0.795.
It is almost 0.8.
0.8. So this is also normal, right? Like that we have to do for all. Maybe one more we will do it, right?
P value less than 0.5 or 0.05.
0.05. 5%. Please remember it is 5%. We are checking at 95% confidence interval and 5% is your risk region available, right? So the alpha is 5%. P-value below 0.5 only we are testing, right? So always remember it is not 0.5, it is 0.05. That means 5%, correct?
Then that
Okay.
is not normal.
Okay. So we will do one machine B also. Okay. So it is again, it's very good, very good. That's why it is showing p-value very high. Okay, it's very normal, right? So normal 0.89. So this is how we have. But the first conclusion is that the data should follow a normal distribution. So that is our okay. So that we tested, right? That we tested. What we have tested? The normality, right? So normality of each data we have tested. Is it okay, everyone?
Yes, sir.
Yes, yes,
Yes.
yes.
Okay.
Yeah.
Santosh, okay. Santosh, okay.
Yeah.
Yes.
Okay.
Fine. Okay, so normality is over. Now one more small complication also there before doing the test. Okay, one it's not complication. One more test you have to do. That's all. It's not complication. It's very simple in Minitab. Few clicks, Minitab will throw you the result, and just look at p-value. You conclude. That's all. That is what the advantage with the Minitab, right? You have to just only thing you should know which is the test to be done. That is our knowledge. The remaining Minitab will do, but you should know what is the test to be done. So whenever you are doing ANOVA, for that
It
matter,
means
all you have to see that normality test, but
it,
I am discussing in this scenario only, right? Okay, so let us see one more. So one assumption is that normality is over. Next is that it should have an equal variance. So what is the meaning of variance? Can anyone say what is the meaning of variance?
variance means it is
Gap.
a difference between upper
Gap.
and upper limit to lower limit.
That is range.
Variation from the
It's
center.
the difference between two things.
That is English meaning.
Variance
We are
from
not
the
asking for English meaning. I am asking for the technical meaning. What is variance?
variation from the central value.
That is the variation from the center value is not variance. That is this difference. Have you all heard about standard deviation?
Yeah.
Standard deviation. What is standard deviation?
Square of standard deviation.
Yeah. Who said this? Who said?
This one.
This one. Okay, correct. See, variance is square of standard deviation. Okay, generally when we are calculating standard deviation manually, you will be taking a square root of certain value. Okay, that's called, if you don't take square root of that value, it is called a variance. If you take a square root of that value, it is called a standard deviation. X minus x bar whole square, xi minus x bar whole square divided by n minus 1. That is the variance. If you take a square root of that, it becomes standard deviation, right? So the another measure of standard deviation is variance, right? Square of standard deviation is called variance, right? Now, what we have to look into is that whether the standard deviation or a variance, if you square it, it becomes variance, right? The variance of all groups should be more or less equal. What is the condition? The groups, what is the condition? Can anyone repeat what I said? The variance of all groups are equal. Okay, there is no statistical difference between each group. So the variance of this group, if I calculate the standard deviation or variance of this group, variance of this group, variance of this group, or variance of this group, all should be more or less equal. So this is another condition. Okay, one is normality to be done. Second is that equal variance to be tested. If those conditions are over, then you can go for one ANOVA. That will give you the best prediction, right? Otherwise, what will happen? It will be erroneous. Whatever you may be thinking may be erroneous. You can do it. The Minita will give you the result. But then if it is not equal, then it will give a wrong assumption, wrong conclusion, right? So that's what we want to see. So for that also there is a way. Stat ANOVA, right? There is a, this one is called test of equal variance. What is written there? Can anyone read what is written there?
Determine whether the variances of the standard deviations of two or more groups differ.
Right? So here also it is mentioned. variances or standard deviation. So standard deviation square is variance, right? That's why it is told that either variance or standard deviation. Either case, it should not be too much differing or not, right? So you have to just click there, and now what you have to do? You have to just because there are all separate columns. So I am selecting separate column, right? Now I am selecting machine A, machine B, machine C, and machine D. Now I have to just say okay. Now what has happened? The p-value has come. What is the p-value?
0.7171.
771. Right. That means they are equal. The p-value is more than 0.5. So they are not significantly different, right? They are all equal, right? It is appearing this is slightly this side, but as per p-value, they are more or less equal, or they are not significantly different. Okay, so the second assumption also cleared. So the first assumption was normality. The second assumption was test of equal variance. If it passes both the case, then we are ready for what is the test? What is the test we are going to do?
ANOVA test.
ANOVA, right? So here there should be some suspicion. The machines are the yield or strength value, average strength value. The strength we are going to see the average load or like strength you can say average load values of the product of different four machines, right? Different machines are not equal. Machines are not equal. This is our suspicion statement, right? So null is that they are equal, correct? Correct? Agreeing? Machine A, average value of machine A, average of machine A equal to machine B equal to machine C equal to machine D, right? Okay, so this is your null hypothesis. What is your alternate? What will be the alternate?
Average values are not equal.
Yeah, no. Here there is small catch. Here it at least one of the average value is not equal to the others. What is the meaning? What is the meaning of this one? English meaning. At least one of them is not equal to the others. What is the meaning of this statement? Can anyone say what is the meaning of this statement?
It means that one is always different from each one.
No, that is not the meaning. Can
There
anyone
is
say?
there is more than one difference among the values. Average values.
Okay, so yeah, we are close to answer. Here it is telling that at least one of them are different from the other. Means it can be more than that also, right? At least one of them is different means it can be at least one of them means it can be more than that also, right? We are checking that at least one of them are maybe all the three are okay. This one alone may be different, or this one alone may be different, and all the three may be different. All the three are equal, right? This is one condition. Another condition is that these two are equal and these two are not equal, right? Similar to that, all the permutation combination, right? So either all the four are different, or one is different, or two are different, or three are different. All these combinations are just by simply one this one. At least one of them is different from the others, right? That means if it is one, at least one is different from the other, then also it will show as p-value as below 0.5, right? If it is more than 2 also, it will show 0.05. But if it is all are equal, then the p-value will be more than 0.5. Is it clear? Or is it too much confusing? Yes or no? Some silence? Yes. Okay.
Yes.
Okay, na? Okay. Okay. Now we will just see the test, then you will have more clarity, right? Okay. So it is qualified all the requirement. What is the first requirement?
Normalcy test.
Normality test. What is the second requirement?
Variance.
Test of equal variance. That word test is called test of equal variance. I have written somewhere, I think. Test of equal variance is the word. I have written. Here it is written. Test of equal variance. Okay, so we have to check for normality as well as test of equal variance. Now we are ready for ANOVA, right? Since it passed all the tests, we are ready for ANOVA. One-way ANOVA. See, you can see a one-way ANOVA, right? One-way ANOVA, right? Now here also we have got different columns. So I am choosing different column, right? Sorry, different column, right? Now I am just say machine A, machine B, machine C, and machine D. Just say okay, you will get the result, right? Okay. Now you can see the graph. Now can you say that which is significantly looks like significant or it is all very random? What about these two machines?
Almost same.
Almost same, right? But between these two machine and this one,
Quite a large distance.
this is a way ahead. Okay, it gives you almost 16 kilo, 15.5 kilo. It gives only 12 kilo. It gives you only 12.44 kilo. So there is not much difference between these two. Okay, but compared to this one, this is way ahead. Okay, compared to these two, what about this one?
This also way ahead.
This is way ahead. But what about these two?
There is significant difference.
This is also significant because you can see these two lines. This is your confidence interval, right? This is your mean value, observed mean value, and this is its confidence interval, right? This confidence is 95% confidence interval, but you can see that this is below that one. If it is no, they are no like this. If it is no inter this one, then it will you can say it is not significant. But here not no, it is not our this one. It is away from this, right? So this also significantly different, right? Now this gives you some idea that which are the machine you have to improve. Your yield is better. The more is better. If that is the case, then which are the machine you have to improve? Higher the force, better the result. So which are the machine we have to improve? The condition is that higher the load, better the result. So which are the machine we have to improve?
A and B.
Machine A and B.
B, A and B we have to improve because this gives you the best results, right? You have to at least bring into at least this level, right? So this is what we have to, by looking into the graph, you will conclude. But ultimately your conclusion is based on p-value. What is the p-value? P-value is 0, 0, right? This table is called ANOVA table, right? So if I'm explaining ANOVA table, you will get further confused. So we will just stick to p-value alone, right? We will learn one by one the details of this ANOVA table, but now I am just limiting to p-value only. But this is also important. ANOVA, whenever you are learning, this is very important table. But if I start explaining you, it will take 1 hour, and you will get further confused. So the Minitab has given a one boon. Just by looking into p-value, you can conclude everything. So here p-value is less than 0.5. What is the conclusion? You have to reject the null.
Reject the null.
Reject the null, right? You have to reject reject the null. We reject the null, right? Or we have to accept the alternate, right? And now by looking into the graph, what we are concluding? By looking into the graph, we can conclude that
you need to improve machine A and B.
Machine A and B, right? At least these machines are significantly different from the other, right? At least you will have a conclusion like that. Because when you say looking to p-value, you are just concluding that you are only concluding that they are different. But which one is different from which? For that you need this one. You need a graph, right? Otherwise you don't know which one is different. You concluded that it is different. But somebody is asking you which one is different. You said it is different, but which one is different? If somebody is asking, you don't have any answer because this p-value will tell you only 0, 0, right? So for that, the graph will support you. or you will get individual average value also. By looking into that also you can conclude, but the best one would be by looking into the graph, right? So by looking into the graph, you will have a better idea, right? So these are all the things. The mean values are given here: 12.44, 12.65, 15, 14. Okay, so all these things are given here. So it's the same thing what we have seen here. So you can look into the graph; it will give you a better idea. Okay, so far okay, everybody.
Yes, yes.
Yes, sir.
Okay, fine, great. So if you have any questions in this, you can ask me. Otherwise, no, we have to think what is next. You have any questions so far? Everybody is understood to some extent?
Some extent is fine.
Okay, okay, fine, great. So, Gopal sir, anything else?
Yeah, I think up to Anava is good. So, participants, do you think now you can also conduct hypothesis testing in your workplace? Right? Can you correlate a similar kind of situation in your workplace? Have you ever made any comparison? Have you ever tried to understand the significance?
Yeah.
Yes.
We'll try to.
Yes.
Try to.
One example. You please bring out that example. Let us try. Which hypothesis testing is best fitting into?
Okay.
Yeah. Let's say we have two teachers here, right? So let us say there are two trainers, myself and then Vinod Shankaran sir. So after going through the training program, and definitely there will be impact in your skill set. Am I right?
Yes.
Now,
Definitely.
whose contribution is going to be significantly higher? Is it going to be mine or Vinod Shankar? So this is the doubt. I'm not actually really comparing, but I'm only giving an example, right? So whose contribution is going to make a significant impact? And now tell me, I wanted to study your impact, let us say based on the test performance, right? Test performance. So you are answering many questions correctly simply because you attended Vinod Shankaran session. And similarly, certain questions you are answering because you attended my session. And now based on your performance in the exam, whose contribution is significant? Now tell me, this leads to which scenario? What is this hypothesis testing all about? What is the name of the hypothesis testing?
Two sample t-test.
Correct.
Correct.
Beautiful observation, right? So definitely, these kind of situation will definitely exist. Let us say you have two suppliers supplying raw material to you. The strength of the material is very important to you. And you want to check whose supplies materials strength is good actually, right? Probably you want to go on the higher side. The material that has the higher strength, you would probably prefer. And now you are comparing two suppliers. So what is this hypothesis testing? What is this?
Two supplier again, two sample t-test.
Yes, two supplier again, it is two sample t-test.
Yes.
Definitely, right? And suppose you are evaluating two suppliers based on the percentage of defectives they are committing. You have two suppliers and the percentage of defectives is the concern now. Now, whoever is committing less defective rate, probably you will continue the business, and whoever committing more defective rate, you will disconnect their contract. Now, this is the decision you have to take. You are collecting data over 1 month or 3 months, and then you are arriving on a decision. And now, what is this hypothesis testing? Probably it was not taught by Vinod sir, but what is this? We learned it in the introduction.
This is chi-square test, I think.
You can do it by chi-square test also, but it is actually, called as two proportion test. Proportion of one supplier you are comparing against another supplier, it is two proportion test. And let us say you have what do you say? 3 suppliers or 4 suppliers. And now all of them are supplying you some sheet metal. In sheet metal, the thickness is the CTQ. In sheet metal, thickness is the CTQ. And whoever gives you the thickness close to the target, you would probably like him. And now out of the 4, you just wanted to probably finalize only 1. All remaining 3 you want to disconnect. And now how will you, what is this scenario lead to? What kind of hypothesis testing it is? Now there are 4 suppliers. ANOVA, right? You can choose 2 at a time and then do it, which is called a 2 sample t-test, isn't it? But we generally don't prefer that. Taking 2 at a time, you have to conduct several tests. Am I right? Suppose if there are three people, A, B, C, A, B you have to do, B, C you have to do, C, A you have to do, isn't it? And taking 2 at a time, 3 tests required. Similarly, if there are 4 and you take 2 at a time, and the number of testing will be 4C2. Hope all of you have studied little max, right? 4C2. What is C there? Combination. Am I right? There is a formula again, mathematical, NCX. So you don't have to get into all those things. So four supplier. If you take 2 at a time, there will be too many hypothesis testing, and every time you conduct the testing, there is a chance of type 1 error. All of you agree?
Yeah.
So in order to minimize the error, we generally don't go for multiple testing, rather do a test in one go, so that the error is minimized, isn't it? That is why instead of doing multiple 2 sample t-test, we go for the ANOVA directly. All of you agree?
Yeah.
Now, any situation is actually a hypothesis testing. You have a daughter and son, a male child and a female child, and you are comparing their performance based on the based on the exam mark. What are you doing actually? You are doing
2 sample t-test.
2 sample t-test. And now your school head HM, he has the population information. The school's average performance is known, and school's standard deviation is also available, because the HM will definitely have the data. Am I right? All the students who have studied in 10th standard in that school, the average performance is available, the standard deviation is available, and that information is shared with you. Now, you are comparing your child's performance in 10th standard against the school average. Now, what is the hypothesis testing you will do now?
One sample is Z test.
G test. If the HM is willing to share the population characteristics, like the school average and school standard deviation, HM is telling you. Now you can go for 1 sample Z test, because the HM is kind enough to share the information. Suppose if the HM is not sharing, then you have to do everything with your child mark only, isn't it? Then the test will be called 1 sample T test. So ultimately, you take decision with the help of the p-value. Now let us talk few minutes about p-value. What is the tool p-value called? What is the name of the tool p-value? P-value means, is it probability or probability of significance?
Probability of significance.
Probability of significance. In order to calculate the p-value in G-test, you require G-score. All of you understand? In order to calculate the p-value in Z-test, you require G-score. In order to calculate the p-value in T-test, you require T-score. In order to calculate the p-value in chi-square test, you require a statistics called chi-square. Right? So you can actually deep dive. And then understand. Now, let us say a company want to produce sheet metal with a thickness of 100 mm. Thickness of 100 mm. 100 mm thickness sheet metal is the product. And you have designed the process so fantastically that every sheet metal that is produced is exactly 100 mm. Do you understand the requirement and the current scenario?
Yeah.
100 mm is the requirement, and your process exactly produce 100 mm. You have taken 10 samples. What will be the thickness of the 10 samples? Each sample will have a thickness of
100 mm.
100 mm. So after 10 samples, if you calculate the average, that will also be 100 mm.
Correct.
What is the target? 100. What is the sample average? That is also 100. What is the difference between sample average and the target?
Both of it.
Both are same. So what is the difference? 0. G score is 0 now. That's all. G score is 0. G score is actually nothing but the difference between the sample average and the targeted value. Clear? Wherever it is not 0, right? In order to generate the G score, you have to divide the difference by standard deviation. You have to divide the difference by standard deviation. Let us say my sample average is 105. My sample average is 105. But what is the target thickness?
100 mm.
100 mm. So what's the difference now? 5 mm.
5.
Now my doubt is how far my sample average has moved from the target. How far my sample average moved from the target? 5 mm.
5 mm.
But I want to know the movement in terms of standard deviation. In terms of standard deviation, how many standard deviation my sample average has moved? Why? Why standard deviation? Because I know something about normal distribution, isn't it? 1 standard deviation, 68%. 2 standard deviation, 95%. 3 standard deviation, 99.73. All of you, do you understand? It is for that reason we always convert the difference in terms of standard deviation. If the standard deviation is 2.5 and the difference is 5 mm, how many standard deviation it has moved? Tell me.
2 standard deviation.
2 standard deviation. How do you get it? 5 divided by 2.5. So the formula for G score is difference in the sample average and the target. Difference in the sample average and the target divided by standard deviation. All of you are with me? All of you, do you understand?
Yeah.
Yes, sir.
Yeah. So you all can see my whiteboard now. So what I'm saying is G score, the formula is X bar minus mu divided by standard deviation. This is the G score. All of you understand?
Yes, sir.
Now, when the G score is 0, look at your normal distribution graph. This is your normal distribution graph, right? G score 0 means at the center, your G is 0. Right? And now G score equal to 0, your sample is exactly on the target. That is the meaning. Now, what is the area to the right of the G score? Can somebody tell me? What is the area to the right of the G score?
3 sigma.
3 sigma.
See, you have to be very careful with the terminology hereafter. What is the area to the right of the G score? 0. Area to the right side. What is the total area under the curve?
50%.
50%. That means this shaded area is 0.5.
50%.
If my G score is shifting by some distance, let us say G score becomes 2. G score becomes 2. Now my G score is here. Now where is the area to the right of G score? Can you see the closely drawn hatching lines? All of you, do you understand what I'm talking? Now this area, will this area be still 0.5 or less than 0.5?
Less than 0.5.
Less than 0.5. So now my G score has shifted by a distance equal to 2 sigma. Am I right?
Yes, sir.
When it is 2 sigma, you all know 2 sigma on the right side, 2 sigma on the left side. What will be the area contained inside 2 sigma? You all know, right? 295.45. Am I correct?
95.
Yes,
Yes.
95.4.
95.45. Now I draw one more normal distribution curve to make it exactly 95. So G scores at the center 0, G score at the left which is -2. G-score at the right, which is plus, oh, not -2. Let me say minus 1.96. These are certain numbers you will slowly start understanding. And here it is plus 1.96. Why 1.96 instead of 2? I want to make it exactly 95%. I want to make it exactly 95%. If I make it exactly 95%, what will be the area outside the line 1.96? This right side area will be 2.5%.
2.55, left is 2.5.
This right side will be 2.5%. So the last 5% of the possibilities are happening beyond 1.96. Can all of you make out my statement?
Yes, sir.
For everything that is happening in your company, we are seeing it through G-score. All of you please understand. G-score is a dimensionless number. When I say thickness equal to 100 mm, it is a number with a dimension, millimeter. A number with a dimension is converted into a dimensionless number, which is called G-score. That is telling you what is happening in your company. If G-score equal to 0, how is your company performing? Beautifully performing, isn't it? The world-class performance.
They're achieved 6 sigma.
Can be much more than that. Can be much more than that. You are on the target. You are on the target. The sample average is on the target. But G-score increasing means your process is deteriorating. Can you all understand? If G-score is increasing to the right side or decreasing to the left side, these are all indication that your process is losing its capability. Am I right?
Yes, sir.
Yes, sir.
You can tolerate the deterioration to a certain extent, but not to the extent of the last 5%.
But we need to control within the limit. Otherwise, we can maintain it in a long time. Means we can lose our business.
Yes, yes. Let us first understand statistically, and then see, always the reality is reality. Though we talk all those things and what can be done, only we will be doing that much in the company, right? So don't worry about the practical difficulties. So now my point is, as the G-score increases, the deterioration also increases. Generally, statistically, deterioration up to 95% is considered normal. Deterioration up to 95% is considered normal. But beyond 95%, you only have the balance 5%. Any event that is observed beyond 1.96 is considered critical. Considered critical or significant. It can be anything. Please understand, it can be anything. It is not only applicable to thickness. It is applicable to blood sugar level also. Fasting blood sugar level. All of you, do you know fasting blood sugar level?
Yes, sir.
Yeah.
Before taking breakfast, they are
Yes, before taking breakfast. What is the ideal range? What is the ideal range?
120.
120, yeah?
Yes, 80 to 120.
Okay, 80 to 120, the center is 100. So let us say any value, if your fasting blood sugar is 100, you are at your optimum health. Am I right?
Yes, sir.
Yes, sir.
The sugar level. Suppose under this condition, when I calculate G-score, it will be 0. All of you agree?
Yes, sir.
Yes, sir.
But what happens? Your sugar level increases from 100 to 105. What will happen to G-score? G-score will become 0.5 or something. Approximately, I'm telling. When the G-score is 0.5, your sugar level is 105. Now, doctor won't be serious because 100 is normal. 105 also normal. But now 110. Now what happened to your G-score? G-score, let us say it becomes 1. Now also doctor consider your sugar level as normal. Now your sugar level is 150. Now what will happen to G-score? Shuma, roughly I'm discussing 1.5. Now also doctor will not take it very seriously. He will simply advise you, okay, you are okay, but keep lead a good lifestyle, and he'll simply advise you, and then that's all. But now the moment he sees your reading, let us say 120 and above, When it is 120,
above the 120 means we need to take the corrective action.
now when the doctor sees your sugar level is 120, he will say, hey, you have become diabetic. Am I right? He will say you are now diabetic. He might even insist you to take medicines. Otherwise, it will affect other organs. Why? You have come to the last 5% of the population who will have sugar level 120 and above. Do you understand? Majority of the people, their sugar level is 80 to 120. Now your sugar level is in the last 5%. How do I know you have come to the last 5%? Because your G score of 2 is more than 1.96. All of you, do you understand?
Yes, sir.
When the G score of 2, G score is more than 1.6, you need to understand you have now entered the zone of significance. In the zone of significance, if you calculate the p-value is nothing but probability of G score becoming more than 1.96. If G score is more than 1.96, then the probability will definitely be less than 0.05. All of you agree with me? If it is exactly 1.96, the probability is 5%. If it is more than 1.96, the left out area will be less than 5%. Whenever p-value becomes less than 5%, you have entered into the last 5% of the population. There are 1,000 people who are writing the competitive exam. You are in the last 5% of the list. Your performance is so bad. Can I say like that?
It's a reverse.
Reverse. Your performance is so bad, isn't it? Because you are on the last 5%. So similarly, you should not tolerate G score going beyond 1.96. If G score goes beyond 1.96, the worst things started happening in your process. Can you make out that? If everything goes wrong, the last 5% of the events will start happening. Imagine your life in the last 5 years of your duration of the life. The toughest time, isn't it? Maybe.
Right. Last 3 years.
Yeah. So similarly, the last 5% of the events started happening, and you have noticed it, you have witnessed it in your experimentation. How do you know it is the last 5%? Through the G score. All of you understand?
Yes.
This, but you don't have to really go through the pain of making all these calculation. You can leave the job to Minitab for some time. All right? You can leave the job to Minitab for some time. Look at the p-value and take the decision. But then it is also the time for all of you to try to understand the basics, which is normal distribution. Try to understand more about normal distribution so that we can teach you more and more. All of you understand?
Definitely.
Unless and until you talk, very clearly about the normal distribution properties, we can't, make you comfortable, keep you comfortable while learning the new things like p-value and all those things. But if you are very thorough with one distribution, I am telling you, all the problems in your company, you will tackle it using the knowledge of normal distribution only. Your process might be following some other distribution, but still you can tackle it using normal distribution, right? So that's it from us as far as the hypothesis testing is concerned for now, but you will